Okay. He's actually going. Okay, great. What's your provider?
Trick.
Bro, it's the same as mine. Except
What phone do you?
it's a S22.
Okay, iPhone 15 Pro.
I have an iPhone 15 Pro. Yeah, there's nobody in it. Okay, so I just showed this with.
No, we're good. The stream's up and running.
If you need to top up your credit on your phone.
No, I have unlimited. Cool. You can just click the live. It's red, it's live. Okay, can I use your charger then in case my phone will go after the 3 hours? Yeah.
Why is it starting more? Don't know. I just need to be more.
Red. Okay, it seems like your charger then in case my phone will go after the 3 hours. Yeah.
Alright, bro, we just rolled it.
Yeah?
We don't have many options.
If it seems to be fine.
Yeah. So what was I doing?
So, yeah, that's it. Let's go back to OBS and we're
I have
go.
to share this.
The PowerPoint's gone off. Why have we lost the PowerPoint? Okay, cool. So if you go back to OBS now, just to see. Why does that show? Okay. That's it. We're good. And then I did the same thing then for, I set this up for the guys when they come in. Do the same thing.
Yeah.
Bring back OBS and make sure it's all working.
You just have to swap with your flick credit.
Yeah.
You got your mouse, you got my charger, you got everything. If you
Yeah,
need
yeah.
anything, I'm just sitting here. Any problem with me?
So for which? For your demo or your presentation?
We have a demo and a presentation.
So for the demo, you connect your laptop to that screen. There'll be HDMI and a USB-C connection. For your presentation, there'll be only audio.
Okay. And for this also we need a HDMI or is cat effect?
So for which?
For the
So for this, the presentation will be on this laptop.
okay on this the one you
So you
submit.
only need one laptop for the demo.
Okay.
That's all. That's fine. I just checked on my phone. Perfect. Yeah. Where is Danny?
The drives, can you put the link over here? I'll give it to you laptop. Please. No need for laptops, no? I offered all of them. They were
my one.
this will be okay. Let's get started.
My one done.
We are ready for you to go. So I checked my phone.
Just remember to toggle this view in case people are
No, I
The last thing
checked.
we need, and we are ready to start. We're ready to start. The last thing we need is the whole sequence of list, all the teams.
There's a red button on the bottom. So that come out? Yeah.
Hey, hello everyone. Hello. So we are
1:45 right now. We're already 14 minutes delayed. Sorry, first of all, for all the delays. Thank you so much, judges. So we have our judges, our 7 judges. We have Austin Coffey, we have John Burns, we have Jane Burns, we have Dr. Jillian, and we have Claire, and we have Shane Gilligan and James Wagner. We have these 7 judges waiting for us. We'll start the presentation very quickly. Some rules before I want to point out. 3 minutes presentation time every team gets. There's a sequence which you might have been made already. 3 minutes of presentation time. You'll be clapped off. It will be very strict. There'll be someone timing you, and they'll be showing you a raise of hand once 1 minute is left and once 10 seconds are left. And then we'll just start clapping so that we're mindful for all other teams. Judges, we have 2 minutes of question answer time. And if you want to take your time, feel free to. But that's the average time which we have for all the teams. So 5 minutes of total time for every presentation, including question and answers. So, are you ready? Good. The first team. Do we have the first team over here? So quickly set it up. Yeah. You can have one laptop over here for all the teams, and the presentations will be popped up on the big screen. So this is team number 1, and I request all the teams to call out your names while you are presenting. So first, talk about what is your team name, so judges know what is your team name. And that's team number 1. Here we go.
Yeah, our team name is Short RAR, but yeah, our project is called.
Sorry, what's the name?
Shark RAR. Yeah, it's difficult to find, but it's Shark dash RARW.
Is it written somewhere?
Yep.
Hopefully, yes.
It's okay. It doesn't matter how you want to say it.
Sharks of this?
Like something with a shark on the It's on.
Yeah. Silent?
Yes. Yeah, maybe. Oh yeah, there. One side. Just bring it to the other screen. Oh, okay.
So the first signal I'll give you 1 minute left. The next signal I'll give you 10 seconds left. Okay, we'll start here.
Back over here now, and I'm going to update OBS over there, and then switch to presentation mode, and then you guys should be ready to go. So
How do I switch it from
this one?
Yeah, hi everybody. Maybe we can start. So our team is called Shark RAR, but our project, let me introduce you to Project Poseidon. We're trying to give the ocean a voice, and the acronym Poseidon actually stands for Predictive Oceanographic Shark Ecology and Insider Data Observation Network. Okay, it's a mouthful, but we're trying to empower marine conservation through innovative technology. Yeah, so what we really try to do here is how could we solve the issue with NASA data. So NASA has a lot of open data, and we're trying to use it for ocean intelligence network. We tried multiple data sets, and we decided during our researches to point to the best space satellite data set that was collected by that mission, the SWOT mission, and the GOES and JPSS. Why did we choose those? Because the base satellite will give us information about phytoplankton and chlorophyll tracking all over the planet. And the SWOT mission will give us information about sea surface heights and eggs and frogs, so whirlpool in the ocean. And the GeoES and GFSS will tell us important information about water temperature. So if you can go next, what we're trying to do here is, okay, here maybe we have a little bit of information overlap, but our mathematical formula started from the phytoplankton blooms because they are, maybe I can raise my voice a little bit. The phytoplankton blooms are at the bottom of the food chain. So we use those as a starting point to look for life. Then we are taking a look at ocean dynamics. So that's what I was talking about eddies and fronts. So the whirlpools that we might encounter in the ocean. We took in consideration trophic lag, which is the time that you need to have more life in the ocean. So it's time delay for food development, and in this case for sharks, it's other fishes. And then we're trying to get a foraging prediction. So it's where sharks will land tomorrow. So in the challenge, there was a very specific question: was find a mathematical framework for this topic. And we tried to get a formula, a very simple one. We tried to simplify it here. And we came out to the probability of foraging is proportional to a function that we created. Maybe we are ready for question and answer. And just wanted to show that we have a web interface. So it's a back-end and front-end system, and we are running it even in a private server, so it's publicly accessible. And we have some tags that we can choose. We have a map and sorry if it's really fast, but do you guys have any questions? Yeah, so maybe it's very fast, but
It's very fast.
yeah.
So tell me, what do you do with the data once you gather it? And you gather it from multiple water or?
Very good question. So we use a library to not put, so we do it every time there is a query or a new query. So we put exactly the data we want. So we use a library to search for the data set itself and filter out the data we don't want. And then what we do is calculate with that formula an index, an HSI is an index that it comes out from there. And as you can see, we take in consideration salinity. So we get it from one data set. We get what's there, the oceanographic. So how deep is the water? So we get all this information, the chlorophyll, the amount it is in the water. Then basically we map it in this map, and then we get one single value, which is this index that we are going to show here. We have multiple values, and as you can see, you have maybe higher concentration in certain areas where the phytoplankton and temperature and the salinity and all this precious information can predict where are the sharks going to be next.
So in your model, when you were creating your formula, did you test that against the data that you had already?
Perfect. So we are not doing any machine learning. We are just doing a prediction model based on a mathematical framework. But what we would like to do is create a new data set from this data to then train a model and then have a prediction for the future. But as you can see, just one last thing is that what we did just for a sanity check is to check this data with live tracking that is open data that is showing sharks at the moment in the water, and we saw that.
Over time you lose points.
Sorry.
Over time you lose points.
Yeah.
Yeah.
Sorry.
Yep.
Thank you guys.
Thank you guys.
So next thing is gonna be space wolves.
Can you say something like noise? Just make sure whether or not
So everyone, it's a sincere request. Please be quiet for the other teams for the loose points we're noting down. So please be quiet.
Hello everyone, we are Space One and we are presenting our project Exospace. So we took the Exoplanet Challenge. So if you notice the picture here, you see that dim there, that's the Andromeda Galaxy. It looks something like this. If you zoom inside here, you see that's millions of stars and potentially billions of exoplanets. Each year, NASA scientists spend weeks, months, and even years of hard work to classify exoplanets mathematically, manually, and it is a very laborious process. Currently, the NASA exoplanet dataset has almost 10,000 exoplanets, out of which 82% are false positive. So, what we are aiming for is a simple ML algorithm to help these scientists classify planets on a good basis. Rather than getting false positives, we want scientists who go through billions of parameters to get actual confidence values so that they can focus on real exoplanets instead of chasing fake data points. So this is what the data set looked like before our ML pipeline. As you can see, there are a lot of false positives. These are the evaluation matrix of our ML model. So as you can see, after we processed the data, we got an accuracy of 91% and an ROC of 96 ROC curve. So we took the features, and next what we are planning to do is we are planning to gamify this as a business, so that everyone in this room can go to our website, play with the data, fine-tune the features, and get potential exoplanets. What we can do next is create a virtual map of these exoplanets to create an entire galaxy out of it. In this way, we can create engagement for age groups of as small as 3 to even adult age groups, so that everyone can instantaneously interact with our web app and get information about exoplanets, as well as increase the data sets that we have. So this is our web app. So instead of chasing very complex deep learning models, since we had a small data set, we focused on a multi-class machine learning algorithm to get the best outcome. So if we, for example, if we play with these are the best features that we extracted. So if you select get prediction, so we can get a confidence value of, for example, 96%. Yeah. So these are all the input features that we refer to while making the confidence value. People can edit all these as well, or play with the 4 main features and get a confidence value. We can potentially have a leaderboard around the world. That's what we are open for questions.
What makes your approach or concept different from existing IDs or solutions pertaining today? Like, what's truly unique about
Yeah, so currently, whenever there is, for example, the Hubble Space Telescope or telescopes take images and data coordinates, there's a lot of time spent scraping through the noise, and there are, for example, 27 to even potentially 90 features for each particular exoplanet. So scientists spend a lot of time manually getting a confidence value or finding a new exoplanet. What we are trying to do is, as you saw, there are a lot of false positives because of that. Because in a single picture, there are potentially billions of exoplanets. What we want to do is, the current practices don't provide good actual exoplanet data. They provide a lot of false positives. We want to reduce those false positives and reduce the amount of time scientists and researchers actually spend on finding exoplanets. Anything else? Yeah.
You're going to have crowdsourcing basically the general public.
Yeah, exactly.
So are you going to provide any training for them or?
No, our site provides basic data about the basic data about the features, what the features mean, and anyone can come and learn about the features, play with the sliders, and get potential data that we can take as data points again and train a potential deep learning algorithm when we have more data. Because currently there is less data. Thank you.
Thank you so much, guys. Okay, the next theme is going to be Cosmo Commotions.
Cosmic commotions.
Just another thing you might have noticed, we clap off at 3 minutes, and if you keep speaking, you will lose your time for question answers, and question answer is for 2 minutes. So total you get 5 minutes. Thank you.
So I think Cosmos Commotion. Right?
Just read it and then I'll start.
So we are the team Cosmos Commotion, and this is the problem statement that we took, building a space biology knowledge engine, and this is the product that we have come up with, is Astronomy, right? So this is us, right? I'm Lakshman, and he's Taran, and then he's Sanjay. Moving forward. So what's the problems that we're trying to solve? What's the headache? So different people have different needs. But then, and data is everywhere. But then, when we actually try to look at relevant data, it's very hard to find. So that's our problem statement. So what are we trying to do? How are we going to approach that? So we are preparing a vector database, right? And feeding it with dataset, and then we will be querying, from the users, from the front end, and then pushing it to our language model, which will go back to the analytics, pull up data from the vector DB, and then come up with insights, which will again be put forward in our front end, so that we can have something actually meaningful, right? So that's and how are we going to do it? What is the outcome? Final outcome? It's going to be a role-based single dashboard for all. So meaning a scientist can have only what he needs in a screen, all at one single dashboard. So that's the solution, right? And we will quickly go to the live demo. In interest of time, we have already copied the right. So we have asked a question explaining age-related alteration in some scientific things, and it comes up with the data. Like there is a graph that it comes up with. There are key data points, and it also cites the sources. If you scroll up a bit, you can see the total publications that we have used to train, and then if you go to the Graph Explorer, so sometimes the output may not be very precise, meaning what actually the guy wants. So let's say we say microgravity, and you ask it to generate a graph, it will generate a knowledge graph, and it will show you a relation between all the publications where microgravity is mentioned. And maybe you can click it, you can zoom, you can click and play on it, play with it. If it's too clustered, you can drag it. So now you know the plant development synchronizes with or modulates with microgravity, which occurs in. So you get that. So there's this connectivity that comes in, and if I'm a scientist, I think I will know very clearly if I have to develop a hypothesis, what are all the connecting points, and then I can go back, maybe look at the citation that comes in. Okay, this is the research paper I'll have to refer to, or these are the people I need to meet with, and it becomes very easy for him to take a decision. So people can take informed decisions. That's all. Thank you. That was what we will do in the future, but in the interest of time, we are ready to take questions. Next slide.
Can I ask a question? From that dashboard that you have there, can you get back to the paper in the citations from that dashboard? Like, can you click on the reference and then read the paper in that interface?
In this interface right now, we have just fed text files, right, so that it is easier for us to, but then that's the idea. So if you look at it, we can directly redirect it to the site. If it's an open source site, then the scientists can directly go through the research paper. That's the idea. But then in the interest of time, we could only do this much.
That's fine. You don't have to have it done already yet.
Right.
And are you intending on having this you can use it on a phone, a mobile device, or?
Again, it depends on the use case. Now, this is research data that we are working on, and most of it is available. Now, there are research data which research that happen closed doors, which is limited to specific organizations, and it'll be based on the jurisdiction laws and things like that. We have to come up with it. We cannot keep it open for everybody. So that's the answer.
And to kind of follow up on that, is this just pulling from this open source data? Could you envisage this being used for, data and papers that are behind paywalls that are under proprietary?
Yes. So now let's say there is enough motivation, and then we get to know that this is a product that can actually solve a problem. Right. That's what we're trying to build. So maybe we can develop this and make it even better for a specific organization or a specific entity, and that can be a very close IP product for them to use. And the model can also be trained with very specific data so that the accuracy is good. Thank you all.
Thank you so much, guys. That was very engaging. So the next team is gonna be Bright Good Programmers. Bright Good Programmers.
Which one is yours? Which one is yours? This one? Yeah, that one. Just not in front of the screen. She wants to stand.
Okay. So, we're like good programmers. We were doing hunting for exoplanets with AI. So we'll just do the live demo first. Okay, so basically, we wanted to use machine learning to be able to predict whether a certain observation was an exoplanet or not, using basically a transit method. So the planet goes in front of the sun, which blocks light, and then telescopes pick that up, and so we can use a bunch of data to basically predict whether that's an actual planet or not. So we're using AI to do this because manually it takes us so long. It's laborious, it's tedious, and it takes people just way too long to do it. You have to like clean up a bunch of data and
On the top of using the machine learning algorithm that we developed, we use a Magno in order to analyze the orbital stability of planets that we detect, and could be implied from the data sets that we got from the NASA open source website. And we also used a KDE to map the probabilities of planets existing in those areas of high stability. And after doing that, we grabbed the orbits, but for some reason that's not here. And we were able to then validate whether or not a planet could not only exist in it, but could also interact with the other planets that were in a known planetary system and still keep its orbit stable over a long period of time. Is it done?
We can see it. We can see it on the screen.
Yeah. So the mapping there shows the probability, the stability of a planet existing in a known system that was available in the NASA data set. So the more purple it is, that shows like a higher stability, which means that it would be able to exist there without being disturbed by other planets that exist in that system already. And there's and there should also be the stability function, but that's not there for some reason.
Could you, just a question, could you describe what the stability output would look like? So you don't worry about bringing it up, just describe to us what it would be like.
It was in one of the earlier slides, but it's basically the exact same, except it shows like where in those stable orbits where it would be the highest probability of a planet actually existing, whereas the stability shows where the best places for it to exist would be. So it sort of validates the stability function and also provides like good data to then put it through the physics simulation and stuff.
That's what you do, your validity and demonstrating your relevance, is that right?
Yeah, and in testing hypothetical planets that were generated from the known planets in the NASA K1 and K2 data sets.
And that's using AI, which you programmed to do.
Yeah.
Okay. What was the other, just quickly, what was the other thing you said that wasn't showing up? Did you want to tell us about?
The boss of the orbits.
Is that track?
Oh yeah, so this is basically showing in between three different planets. Two of them are actual planets that exist in the NASA data set, and the one that's in the middle is one that was a hypothetical planet generated from data that we got from our machine learning program, and it's basically showing that the orbit is stable throughout a long period of simulation. So that sort of validates that a planet could exist there and also be stable over a long period of time.
How much better is your prediction compared to the standards of NASA?
Yeah. So the standard is really just a planet could exist within these spaces, but with the probability and stability functions, we're able to tell roughly where it is on top of that.
Thank you so much, guys. Couple of announcements. From now on, try to keep the microphone a little bit closer to your face, because from the back it is not audible, as well as please try to keep your phone silent. The next thing is going to be camel case.
That's our challenge.
Oh, okay.
described by meteor for madness.
Right.
Well, there seems to be two of them, so it's, I think we'll meet all in the...
Oh, not yours?
That's not us. Wait, what was this?
This.
Oh.
Come
Yeah,
here.
that's us, yeah.
Sorry.
Okay, lovely. So, hello. I suppose I'll start with an introduction as to who we are. We're all first year computer science students from the University of Limerick, as you can tell by our amazing yellow hoodies that we share. And I suppose we should start with what is Meteor Madness, and it is a challenge designed around the simulation and modeling of asteroid either impacts or near approaches to Earth. I think it's of course important to mention that this project is in the public eye a lot because of the recent news of a potential impact in 2032, which I think is gone now if I remember correctly. And those are the technologies that we felt were most necessary for this project.
I just want to quickly run through a tech stack here. So first we have a web app that all it is for interactivity. And then we use Unity for like gamification and then we use Unity to take in our APIs from Python, and then Python takes in APIs from that.
So I suppose we should we talk about the impacts that our projects could have. Of course, the main one is in education, educating students about maybe orbital mechanics, physics, and the science of asteroids, and of course mitigation strategies that could be used to avoid the worst effects of an asteroid strike. Nowadays, when we hear about space and technology, we mostly hear about it in a very doom and gloom sense. So it would be nice as well if we could if science could make the news for something positive or something educational. And finally, of course, NASA could use software very similar to this in their data analysis to, I suppose, simulate what the damages could be or deflect them as they've been trying to do with their DART tests. Okay. Full disclosure, this version of the project was built in a car on the way over, so we might... we can't be the first project to have a live demo fail, right? Surely not. Running it in the background while we're
yeah, just bring it over. Bring it over. Is there something like demonstrate?
Alright. So basically the way it works is we have it connected to NASA's big database of meteors, and they have a bunch of data about if this did impact, how much speed would it have, how much energy, how big would the crater be. We essentially took all that, we graphed it all, and now we can, you can make your own custom ones, or you can take ones from the NASA database, which if we demonstrate by typing in the ID there.
Keyboard for that.
So this is just like a random did you see it right there? So now I know this is weight. I hope this is the right angle. Eventually you should notice a little whiteboard somewhere. Oh yeah, there we go. And now that should impact, and it's a little much right now, but it basically we've made destructive terrain to implement how it would actually deform the Earth as well, and the impact it would have on the surrounding area.
Now, the most important part that we can increment on this project is with a topographic map of the Earth. We weren't able to make it work at 2 a.m. this morning, But that is, of course, something that we will focus on in 45 days, given the chance.
Any other questions? In one or two sentences, what exactly is this entire project about, and how can it actually better the lives of people with renal?
It's designed around simulating and mitigating asteroid strikes. So NASA could use this to estimate where an asteroid would fall and allow for and plan and prepare for that.
And that all that data currently exists, but you're using
modelling and simulation.
Different model and simulation compared to examples.
Yes.
Thank you guys. Next team is Backseat Warriors.
So that's the backseat.
They were actually in backseats.
Hi everyone, so my name is Ty Dowdle. I'm a student in ATU Sligo studying software. So we are the Backseat Warriors, and the project we went with is called BioCosmos. So the challenge we picked was to build a space biology knowledge engine. Next slide. Yeah. So our vision, what we wanted to do with the project. So we wanted to unify scattered space biology research and have that in a one-stop hub all in one dashboard. So the tech stack we use Next.js for the front end and Flask in the back end. So we wanted this to sort of empower students, scientists, educators, lecturers to sort of get intuitive search and AI-driven insights, and then a visualization of charts. So some of the key features we have is topic trends. So we have a bar chart visualization to show different trends, and this can help identify progress and gaps. So maybe one topic is heavily researched and one might not be researched as much. We also have a smart search and AI chatbot. So this is used for natural language, so you can just type a question in and you get a summary or a feedback from the AI, and you will get the most relevant publications based on that. Then obviously you get your research results, which is instant results with titles, summaries, and a direct link to the page. So I have a quick demo video here as well. No? We can do it here. So if we go into the dashboard here, we have the bar chart visualization. So we have the different topics. So you can see some topics are more researched than others. Then you can search a topic. So we could search, just for example, micro. I don't think it's running in the background, but basically you just ask it a question as well, and it will give you a summary or some sort of response and give you the most relevant publications. But yeah, that's basically it. If you have any questions.
Function there. So is there an advanced search as well, or is it the one box for search?
Yeah, so the search it sort of takes out keywords and whatever you're searching, and then filters that based on the different publications. And then you can filter based on topic as well. So
you can filter after, but you can say go in and open an expanded advanced search and put in your own search criteria, saying like author. Or
no, that would be a feature that we would like implement down the line, I imagine. But you can also search, when you ask a question into the AI chatbot, it will then give you the most relevant search, or the most relevant publication based on that search.
Okay.
So really it's just a tool for students or lecturers that are kind of in the
So
space
you
where
could ask the chatbot, you could ask it like in the form of a question rather than doing a search for a specific topic. Okay, that's great.
Yeah.
So my question is, how does this fit for a database? I mean, does it link with the data sets, or how does it, you know, we have lots and lots of databases that do this already.
Yeah, so I suppose the main difference is I wanted to sort of be a dashboard for students, kind of, or people, like as I said, students or lecturers that want to search with natural language. So as I said, you just ask it a normal question, and then based on that you get the most relevant answer. Whereas most databases have obviously thousands of research papers, and they're often hard to find. So that's kind of the idea.
What's the next step, the future potential for this dashboard?
Yeah, I suppose you probably, at the moment there's only 608 publications because it links directly to PubMed as well. So I suppose you want to just have it as a space where you can get all the data you can possibly have on space biology in one space that researchers can go to.
Thank you. Next team is Billy Day. Billy Davi.
Imagine you've been planning a sunny day and you're excited to go out, but once you step out, you realize that your nose is itching, your eyes are teary. In the worst case scenario, you have an asthma attack. This is the case for most people who are suffering from allergic pollen allergies, and this is why we came up with PAM, a solution to this problem. My name is Fatma and I'm business developer of this group.
My name is Victoria and I'm a developer. I'm Mavis, I'm a developer. And I'm Casey and I'm a developer, and the challenge we chose is Blue March.
So, over the years, allergy sensitivity has increased tremendously, and the pollen seasons are also growing and getting longer due to climate change, global warming, and all that. And the lack of reliable long-term pollen forecast is also a problem.
So, our solution is PAM. It's a pollen alert map, a web-based application that provides daily and 5 days forecast for pollen, and we provide a 12-period extended pollen forecast as well, interactive pollen alert map, and info pages on pollen types.
So how does this actually work? Our real-time data uses pollen maps and geolocation Google APIs, and the user can search a specific location, as you can see on the demo here, and that will call our API. Our API queries the data and returns back our visual demonstration here to display different pollen from trees, grass, and different weed plants.
So for the extended forecast of 12 periods, how did we did that? We got the data from NASA Earth data, and from the model satellite images, we got the NDVI value, which is the vegetation index, which means, basically it means that the more active the plants, the higher index is, so it directly correlates to the pollen index, and from that we use a simple mathematical calculation to predict 6 months forward. And also on our page we have an info page for pollen types as well for education purposes.
So we faced some limitations this weekend. Obviously we had a limited time amount to do this, so we didn't cover as much as we would hope.
And also, through our research, we found that the data is actually very limited. So the way we were able to visualize this and the predictions as well were quite limited. But we have a certain area that we can cover for that. Thank you very much. Any questions?
Just ask you about when you talked about the different types of pollen, are you thinking about some sort of a public information campaign alongside the tool itself?
Yeah, possibly. We
Some
have
education maybe.
Yeah, so it would be especially helpful if anyone knew their allergies, so they can specifically have a look and see what affects what where. And the good thing about Google API is it lists what kind of pollens, what kind of different grasses.
Did you get this from a
So they have a whole list of what sections where.
You say the limitations currently are based on the data sets that you've access to, and that's the NASA data sets. What next steps would you go to in order to ensure that it's a much more comprehensive and globally, geographically relevant data set?
Yeah, for sure. Google API covers 65 countries, but not as in depth. So the example you see here is North America. But Mavis was training this, was getting the data.
Yeah, I was getting the data from NASA data, that's the satellite images. We focus on Dallas for now because that's the time we have. Even though we don't have Dallas and it's only for 9 months data, we have 2 hours to get the data from them. So if you want to train a model and get it for the whole world, it's possible, but it will take days to get the data from. So for time we have, this is what we got.
I see that you have recommendations for stay indoors, take advantage and things like that. Is there scope to integrate those recommendations with, say, health apps that people are already using on their phones?
Yeah, we actually originally had an idea to maybe even create this as an app people can include into their Google Calendar or something, but due to us being app developers, we were we're not going to go with that. But it's definitely something that would be good to have, and even a login feature, something that is unique to the user. Yeah.
Thank you. Next team is MCC.
Hi everyone, we're the Merge Content Group, and today we'll be presenting our presentation on how we're going to solve our challenge on Nature Madness. I'm Maxine, I'm one of the developers.
Hi, I'm Daniel, I'm the team leader, and I'm the developer.
Hey guys, I'm Sebastian, good to meet you guys. My name is Daisy, I'm also one of the developers.
And hi, I'm Jenny, I'm also a developer as well. So what is the challenge? We choose Nature Madness because the problem is that nowadays we don't have enough tools to actually allow the public to visualize and see the simulation of how the nature impacts the Earth. Even the NASA data sets and websites is too complicated. There's so much information in it. So our solution is that we gonna create a simulation or visualization using Unity to actually showcase the impact of the nature using heat maps and the data set from NASA.
Okay, so now you'll see a video of the actual app working. So in this scene, in this demo, you can see that we have 2 screens. I don't think the videos work.
Apparently, I think the video doesn't play when we put it into the presentation, but so
Do you have the video on?
actually we have the app here. If we currently here, kind of.
has to be looking, not now, but if you replay the tab, please.
Okay, okay, okay.
So you have two screens, one for the actual Earth, there's a camera stuck to the Earth, one which shows the impact. So if you go to it shows the heat maps which reside based on the density, so known as the speed of the meteor and size as well. So the faster it goes, you'll see a red spot in the middle here, a little bit bigger, and the actual heat map will be bigger as well. We also show some consequences here as well, like let's say it hits the Pacific Ocean, it will cause a tsunami, earthquake. Any questions for now? Also, yeah, we have a load data from NASA, so it fetches data from the API, from the NASA EO. We get the data, we can then load the data here, it will open the load.
So would users interact with the app?
Yes, we can fully interact with it, yeah.
So it wouldn't be published on an app, on a website? It would be
It will be open, it will be published on as a website, on an OpenGL, we can publish it as an application as well. But as you can see, so those are real asteroids. They're placed at the exact, like approximate size from relative to Earth. So they're quite far away from us right now. But you can play a simulation for each one of them. You can there's a button to play simulation, and you can see how they differ, for example, based on their appearance size.
And the impact consequences, are they things that you determine yourself, or are they from the?
These are determined based on the calculation made through Unity with the size and the speed of the asteroids.
Who's going to use this? Who's going to use this?
People in education, teachers, policymakers, any scientists that will be interested in this. It was always fun to try things that are similar things. It's always interesting to know.
How is this different from any other simulation system?
This is very scalable. So right now,
Yeah, you can see that it's actually explode and then
the asteroids right now are just simple spheres. But the thing is, it's very scalable since thanks to Unity, you can drop in the value of stuff very easily, and you can make UI extremely friendly. And that's what the key. The goal is that we make it in between, not too technical, but not too simple either. So users can actually interact with it, but also have enough data. So like when you go to each one of the asteroids, it will show data here, current object, its name, distance, relative to the Earth, speed. Yeah.
Okay guys, just want to remind everybody that the training starts from when you start loading the Maya. So next theme is ingenuity or ingenuity.
I was like sent not like this presentation because I had like the wrong name in the like last slide, and can you please don't show this slide please? Thank you very much.
Of course, we'll also wait for the slides to be up to set time of the work.
Hello all. My name is Ingenuity. Therefore, I want to introduce my team. It's like this guy is Ivan Kraskov.
it's like the developer of this one, he was like did the half of the like technical part. This guy is Vadim Pascal. He did like the research in this like in
Tell us
this.
about the project. You only have 2 minutes.
Okay. Okay. Firstly, our challenge is the world is like in global changes. Therefore, we need to think about it and to do the program or etiquette. We was did like desktop. Therefore, we want to show you like more technical part than like presentation part. Okay.
So we decided to take this challenge because it's more interesting. I think we have quite a good amount of I forgot this word so you can use it in many ways. Yeah. And also there's a big amount of data available. And at first it may seem like simple, but when you combine different sources, you can come up to some conclusions and make predictions for many different applications. So we focus on getting the basic the main method to create we find general approach to combine to attach any API from different sources and in the future to make general format.
Okay.
So we can convert to this general format and using one app and layer up the data and we can make calculations because it will be in the same format. It will be easier to make different predictions for different reasons whenever you want. But it's time is limited. We spend too much time trying to access even one app from NASA HSL, like 30 meters, in first thing we focus on intensity of the plants blooming in certain regions.
So what we're seeing on screen there, can you explain what's on that image?
This example is we take Netherlands because they have in the whole year it's quite too much different species of plants and but usually there's flowers, so they constantly grow your bloom, so you can easily see how much is gonna heat map, how much is blooming,
And how are you extracting that data? Or where are you extracting it from?
We use CRM, NASA search website. We use HLS satellite. And this we use in VMI, plants, we calculate this green spectrum changes when when it starts blooming, light reflections changes. So we can make from this conclusion that it's blooming right now, and we can build a heat map.
You mentioned using or being able to demonstrate different layers.
Yeah.
What are the particular layers you were attempting to be able to show in your?
We can show this right now, sorry. Because that doesn't have enough time.
Would you just explain?
Yeah. You can imagine one map, and it will be different layers from different sources. You can connect them in a general way. So you can layer them up So,
And who would be the user of what you've created? Who would use this?
it can be
Your colleagues.
It's like not only for farmers or ETK, it's like for like usual people who not in like global farming, ETK, therefore that person can understand to see how it is blooming in his or her area and to see how it's implement in his or her area to his or her city or town, etc. Because I know that like other stuff, etc. Due to climate changes and due to this one card, this one map, you have an opportunity to see is it global warming is will like to change climate in like your area, or it's like will be not in your area. Yeah. To see and to think what you need to do in.
Thank you guys. So next thing is gonna be astronauts.
Mine's on. I'm done.
Okay, so we're astronauts. We chose the Meteor Madness Challenge, and our problem statement is just to make the NASA Asteroid API easier to use for policymakers. So there's a lot of data available in the NASA API, but it's kind of hard to access. There's over 40,000 asteroids, some of them as early as the 1900s. So if you don't have data skills, it's kind of hard to make decisions. So we created a tool that it allows researchers to visualize the threat, assess the impact probability, create a policy briefing, and make data-driven decisions. So our solution, it's a 3D model front end with 3JS, where we can get data about each asteroid from the NASA API, and we can picture the flight paths as well as see other information about them. It sorts them based on the Torino score, and then it visualizes the flight paths, and we can generate AI reports. So we're moving on to the demonstration. As you can see, this is our 3D model. We have a slider, and the further you go closer to 1, it goes based on importance. If you just click on an asteroid, it shows you the flight path and the impact, as well as some statistics about it. And then you can also click here, the NASA JPL data, the link. No, click on an asteroid. Yeah, NASA JPL data. And it brings you to the actual NASA write-up on the asteroid itself. And then go back and click off. And then if you press generate report, now this will take a bit, so I'll walk you through it. We're sending all the asteroid IDs back to the back end, and it goes through here it is, quicker than the top. It generates a report using the OpenAI API, and has visualizations for the non-hazardous and hazardous. You can export all of these as PNGs. And if you scroll down to the next one, if you hover over one of those, it shows you what asteroid it is, the size of it, and the velocity and other key factors. If you keep scrolling down, it has impact scenarios, specific mitigation strategies for the asteroids of importance, and recommendations to take. in order to, yeah, mitigate asteroids. Sorry if that's a little fast, just stressing the time, but do you have any questions?
What makes what you just presented to us there different or unique compared to what currently exists?
So, a lot of the asteroid things are just like you will see the velocity, you'll see it hit the Earth, it will expand. But this generates already like reports, so you can look into that. Obviously, it's AI, they can fact check it, but it gives you a good starting base, especially if you don't know any data skills like Python or anything like that. So it kind of puts power in people who don't have those skills. Anything else?
How often would you be able to update the data of that space?
We actually have a scheduled cache, so it updates. We have it just on a sleep timer, but we could use a layout function. We're using an SQLite database. It updates every day. We only have 160. There's 40,000 because it would take 1.4 days to crawl all the API, so we didn't want to do that. Yeah. Anything else? Yeah. It's not completely accurate, it's kind of primitive calculations. Yeah. It's more based on importance than actual distance. Okay. So the closer you go, the more impact it'll have. So if you click on the outside one, it'll probably say safe. Okay. Like, maybe we should slow that down a little bit. Yeah, so like a low threat. Yeah. We had one, but it looked a little bit bad, so
What next for this project? Where are you taking it at?
Well, I think we built a pretty scalable system with caching, so we're not going to get timed out by the API. So next, some UI things like a pause, as well as maybe using a stronger model for the report for more accuracy, and then maybe a machine learning trap, because we're already pulling the data into a cache, we might as well send it through a model.
Some filters for dates.
Oh yeah, you can filter per date. We were thinking of adding that, but added some complexity that we were already too far to go back on.
You're saying there's a really lot of old data. Would this help you clean up the data to get rid of?
I'm not sure if this exactly would clean up the data, but it would give you people who wanted to clean the data the right idea of where to start cleaning the data.
Thank you. So now we will go for exception 404.
Alright everyone, hello, my name is Jerry, I'm from Exception 404, and my project for today is I'm going to present to you the true radar looking glass, the big one. And then next step. Thank you. So, the threat is here because the Philippines has a fault and it is called West Valley, and it might occur or not, and because the goal of this project is to get the area, and my area that I take is from the Philippines, the West Valley Fault. It focuses on the Metro Manila, and if this happens, that is 7.2 earthquake. That's very catastrophic to the area, and we need to be aware of it. And how do we do it? We will use the synthetic aperture radar. It sends the electromagnetic back to the earth and then receive it back. So it's an active data collection and also wide range application. And we also practical because we don't need to deploy long satellites to get the precision of the data. And so it's practical. And then after that, we will compare the images and from the previous one and then from today. That's how we will determine the land changes, if there's a coherence loss and backscatter for landslide. So that's how we will determine if there's a land changes occur near to the fault line. And then after that, we will going to display it in a UI. So we will somehow publish it to public domain and use it by the government to have public awareness. So we will have people to look at it if the area is affected. So we can scale this out to other countries and to help because Philippines is not the only one has a fault line. Everyone, we have the ring of fire, so we must take care of it. Look at it because it's not the world is in turmoil, but I think this one is really the big to look out. Yep, that's all for me. If you have any questions.
Can we see a demo maybe?
Yes, sure. Yeah. So here I have a sorry. Hello. So here we have a sample street maps, and then I use the points that generated from the SAR Sentinel S1 and produce that JSON endpoints, JSON points to map out in the Google Street Map. OpenStreetMap, and then displays the area, and then if your how many deformation it occurs. So yeah, basically just points of the data, but it shows you the importance of that points because if your house is near on that, so you better be careful.
How many people worked in your group?
Only one.
Oh, just you?
Yes. I summon a lot of personas. Even my schedule, I summon my schedule. Yes, okay.
And can I ask, is this designed to be used like as emergency situations? Like how far in advance of, say, detecting changes in the land is likely that, an earthquake could occur?
Right. So right now the SAR is processing a lot of data, so we need to have a lot of machine power. But as time goes by, we can determine it by the land change as we get the data and then process it and update the points that we are having right now. Okay. So that detecting if there's a land change, we will update the endpoints.
So that enables you then to predict when earthquakes
or the possible, because we don't know how fault line is, how long is the fault line, so this will also help us determine how far it will go. Right now, that's what we know, but based on the SARS data, we can predict and we can identify the known faults. Yeah. And we could probably get some proper actions and mitigations for those risks.
It's pretty portable, it could be adapted to other regions of the world.
Yes, that's really my objective because it's really, it happens because there's a recent earthquake on our country and it's really unfortunate for them and a lot of people died.
Next are Celestial Minds.
Hello everyone, we're taking Celestial Minds. I'm Juan, this is Abhijit and Ravi. So the challenge that we have chose is to build a space by using knowledge engine. So basically what our project does is, so there are around 608 publications which have in detailed knowledge and the procedures on how biology experiments were conducted in space. So what our project does is exactly, it extracts the data from all of these publications. Then we have an interactive dashboard where users can ask their questions, and our model, it paraphrases the information that has been extracted from the publications and answers all the questions asked by the user. So our model also helps in summarizing data if the user wants. So the basic core tech that we have used here is to use AI and also create knowledge graphs to make it more understandable for the common public. And some of the key functionalities include paraphrasing the whole text that is extracted from the publication rather than giving the whole content as it is, and also summarizing if the user needs.
Now going to the flow diagram, actually we are just fetching the data which is in form of an unstructured data. Then we are converting the data to a structured format. Then we are performing data cleaning, which includes removing extra spaces, removing special characters and the other things. And then we are constructing the knowledge graph, which represents the nodes and relationships of each, like different keywords. And then we are performing training of the data. In this training, we are classifying two types. One is semantic search and other one is summarized data. In semantic search, when a user, it's a kind of a chatbot. Like whenever user has a query related to any biological data or data related to NASA, space and all, he can just enter that query and it will give the solution, top 5 answers. And the other summarized data which will give the summary of the data. If user wants to learn something about the biological data, he can just use the summarized data, and we have this hosted in the web. We have used Streamlit. And the future outcome is we are just planning to train more number of publications and to improve the model's accuracy. So this is the demo. So this is the semantic search. So when the user enters the query, for example, how does the microgravity affects the bone density of astronauts? It just gives the top 5 results with the metadata ID as well as the score, which is the accuracy. And the other one is the summarizer. Yeah, like if a user wants to want the summary for the and this is the knowledge graph. This represents the common keywords, different keywords, and the relationship between those the sentences.
Is feature importance built into your knowledge graph?
Yes, feature importance is built in. Yeah. That represents the relationships of each sentence or each words.
And is the scores available on it when you hover over?
Yeah.
Yeah.
How is, oh sorry, are you still on?
Yeah. Yeah, that's fine.
And how is the summarizer that you make different to the abstract that is already there for the paper?
Yeah. So for summary, we have just planned in such a way that like the user doesn't need the whole. He can't study the whole paper. So we have just took the content like the abstract, the results, and conclusion, which gives a summary like what the whole data, like what the whole paper consists of. So that's the summary. Yeah.
So a lot of scientific papers, especially in this area, have a lot of visuals, illustrations. How does it extract those meta tags and put this in terms of the validity of the article for retrieval?
So for now we have not worked on the visualization part, but that is like our future outcome. And also like we wanted to build a knowledge graph on all the publications and wanted to deploy this on some graph database or something and build an RG kind of model so that it provides actually it provides a lot of insight and also provides a knowledge gap, like whatever the user wanted to understand. Because it's a whole lot of data, and if we provide create a proper knowledge graph with proper ontology, which is having proper subject, which is related to some object, then it provides a lot of context to the user instead of getting through the summary and all. So that is our future outcome, to build a graph database or something. Yeah.
Because they tend to have a lot of visuals because it's hard to understand. That's why the visuals help. Yeah, good idea.
Thank you. So the next theme is no packets.
On the bottom now?
Hello everyone, we're Team No Packets, and today we're going to be presenting to you our 2025 Athlone project. The project we chose for this event is Will It Rain on My Parade? To keep you up to date,
It's not. The OBS needs to be set.
I'm sorry, there's some technical difficulties.
It's not OBS, it's the projector. No, it is the projector the problem. So
Thank you very much, I'm so sorry.
it was the projector.
Yeah,
Sorry.
that's fine, thank you.
Alright, so for this project we chose Will It Rain on My Parade. So to keep you up to date, this project entailed the creation of an Apple website with a personalized interface, which lets users conduct a query to return the likelihood of very hot, cold weather, windy, wet, and cloudy, based on the location and time they specify. We met the objective that we made for ourselves to achieve within the 48 hours, but we plan to continue the development for the 45-day deadline. We don't have it completely done, so consider it a prototype. For this, we made a website, and choosing website was a conscious and deliberate choice on our end. We value accessibility, and we believe that information should not be exclusive, and we strive to inform. To give credit to our team members, we have two team members doing front end, me and Kevin, art done by Ariel, DevOps done by Christian, back end done by Tiana and Connor. And our group name comes from an inside joke from our class's Discord server, as you can see up there. We were originally entered as a group of 5, but then we found Christian and we became a group of 6. We were very grateful for this opportunity to meet and socialize with plenty of new people. Yes, this is the challenge overview over here. This is just a sneak peek of our process: pixel art and drawings, animation, and website layout done by Ariel.
She learned and adopted the pixel art style just for this project. Front end done by Kevin and I, with the help of Christian with DevOps. And you can see the JavaScript file on the very left. And you can also see that there are issues that we stumbled across along the way. You can see the date, the years, like the values aren't valid. Next slide, please. Here is some stuff I worked on with some placeholder images inserted. And lastly, backend by Jen and Connor. And here is data from the NASA Power API, which has lots of weather data. Two of the images show self-created databases, the one on the left and the one on the very right. These images show self-created databases used to create artificial neural networks for different types of weather conditions. And in the middle photo, it is the training the neural network with a CSV file created with Python. As I said, our final step to completion is linking both backend and front end. Currently, the results is based off of how severe the weather conditions would be relative to Ireland. And yeah, thank you. Alright, so we would have liked to demonstrate our project to you guys, but it is not connecting. So
just bring the laptop.
Yeah,
Is it on the laptop or bring the laptop over?
So this needs to each, and then like we have a selector for the countries. We use the API for the other countries.
So how does this differentiate from there and other
or
So I would say premise of past differs from most weather prediction websites and apps. In the way that, well, we are using data that was collected by NASA from, I don't know, to be honest, how many years of, well, we're using data from past 20 years. Data collected a lot of data which could be used to predict what happens next just based on statistics and what has happened before. As far as you know, most meteorological websites don't work like that. It's
okay, so it works differently to those apps. The end result might be
different, yes. I can say that, for example, for temperature, prediction with temperature today, this model, it is usually accurate to 1.5 degrees, I believe, for predicting weather or temperature for
So what are we going to give us a little rain cloud?
So it's like an example and
so
like
example of what? It's like
I'm
rain.
saying, that's basically just, for example, you're supposed to include like how heavy it is and how much rain there's going to be around that time. So that's why they're doing it. But so it would be, there would be usually information about that. So it's kind of like an recommendation.
And do you think weather services would also want this? Like there's another way?
Yeah, but at the same time, it's not just resources. At the same time, there are other people as well.
Okay.
It could also probably help to give a different perspective on what might happen.
Triangulation of data that they might have.
Well, yes, just kind of a helps both perspectives and see which one works better.
Thank you guys. We're gonna take a 5 minutes break now.
I'm so sorry about the complications.
So, our app, it informs users of weather conditions, it forecasts the daily weather, and there's a location picker functionality. For our app, we use React Native. We made a mobile app. React Native is good for mobile apps, of course, and it's good for iOS and Android. We also got an API which gets the weather. User interface. We followed design principles, and we got user experience also. And that's our UI for the app. Future enhancements. Yeah, so maybe in the future we can have like severe weather notifications. Yeah, maybe deploy it on like the app store or something if you get funds, and we just want to engage with the local community. So yeah, we're gonna go to the demo now.
you going to correct that?
Well, if you see our website right now, one thing which we spend most of our time was to make sure that we use Route React, so that to make the website more usable, more friendly. But we weren't able to achieve that, so that could be one. And also, we could use algorithms like there's something like the Aveda like salsa algorithm, or maybe like digital algorithm to find the shortest route. So suppose if you know that there's going to be impact in Mumbai or like some areas nearby, if there's going to be an earthquake of 6.7 magnitude or 5 magnitude, what can we do so that we could eradicate or we could remove people from there and move them to safer areas and make sure of the safety of those people. So using an AI-driven decision-making algorithm, we could use that to make it a better website. We do have a website like that. We did a pre-recorded version. We're more than happy to show you like a demo, like if you would love to see it.
Thank you guys. Next thing is gonna be Zel Bobiski. Let's spell it right.
What's your name your file? What's your name your file? Can I you needed to name it. Sorry, wait.
Hello, so my name is Athlone, and I'm happy here to be with my team and present the project that we did. The project that we did is called Sharks from Space. It's obviously one of the challenges. Next slide, please. So, our introduction. We're a team of developers who specialize in data, in AI, and backend stuff. And we actually did a project that will help people in all around the world to be more safe, help researchers to be more accurate, and help actual ocean to be preserved and preserve ocean life. So how we did it? Firstly, sharks are cave predators. They are making the all job about stabilizing the ocean, and it's actually so hard to predict where they will be. Next, please. So what we did is first we wanted to make a mass model, but it won't be very accurate. So we made an AI model that actually predicting the sharks based on many information from the NASA's links from the ocean, like with sensors, and we did an AI model, multitask model that can predict where the sharks can be. I would like to give a word to Rodion, my teammate, and he will talk about datasets and how it works.
Hi everyone. So the datasets were taken from the open source website, and they were analyzed, then cleaned, and then it was like a special progression chain, such as gap filling and normalization. And afterward, we got like three files that were sent to the front guys. Yeah, so you can see at the very top how our site looks like. You can see sharks and level of chlorophyll. Also, it should be temperature here, but it's the old screenshot. So yeah, you can see like the addition between all these three characteristics, and so it's like a geo point. If you put to the Antarctic, you can see that it's small amount of the sharks there, depending on their these characteristics. So next slide. Yeah, and what we're going to do next? First of all, we have to develop our MVP because we did it for the first time. Yeah, and afterward, next year, we can develop our model to say not just that it's sharp in this area, but it will be useful for users. If they go to the sea, they can see that on their seaside it's sharks, and that it's dangerous to go today. It's like a prediction. Thank you for your attention. If you have any questions, you can ask us.
Who do you think would use this application?
I would like to ask a question.
I think this project will be helpful for the researchers because the AI will implement the datasets and it can educate itself after education, and it can fill the gaps in the missing points in datasets because there sometimes have signals and sometimes have gaps. AI will clean them and help it. So researchers help public safety on the beaches and of course help preserve the life in the ocean.
What makes your approach to this different than other teams around, to the best of your knowledge?
Our approach is different because our approach is to make a model that solves not only the problem of prediction, but also the problem of inaccurate datasets, and actually it make it easier for researchers and guys with that hobby and all of people just to make the datasets more.
Will be cleaner the data sets as they come in, is it?
Yeah, it can be cleaned, but also AI model can fill the gaps in the dataset based on a previous dataset that it was trained in. So we did one big dataset, we cleaned it, we made it so good, and we tried it with some datasets with gaps, and it was filling the gaps. So it's increasing accuracy of inaccurate datasets and broken datasets that can be from books and samples.
Were you able to estimate how much better your model is to what's existing out there?
Actually, right now, I don't think it's better, but we will do everything we can in 45 days to make it actually bring the best ideas and bring the best project that we can. Thank you very much.
Now it's the turn of Wednesday Wings.
What is the keyline so I know? And then look at the what do I press then? Oh, just and then the arrows.
Right. We're Wednesday Wings, we win the Wednesday. Let's go. The problem with trying to find exoplanets is that there's huge issues with data. So what happens is the light curves orbiting stars are very faint, which they can tend to lead to very slight changes in data sets, which lead to very loud and noisy data, which for models is a big issue. So the main process here was that we need to, the main push to technology, because with new projects like Plato, which launched last year, it's a satellite project which is designed to try and find exoplanets. It's only about a year old, but it's still new data coming in. It's more modern data, more modern experiments coming out with all these types of technologies. So what happens is all new data coming in, we need a new artificial intelligence method to transfer back data, to sanitize it, so it becomes a more usable model. The data value we got was mainly from the two things, from the Kepler and TESS missions, which we got through the NASA data sets, and the research papers that came attached to the information we were given for the project. What do we do? First, we start with ingesting the data sets, which I mentioned before. We then have to sanitize the ingested data by removing outliers, empty fields, and also start taking some data sets which were in some HTML strings and converting them to numerized data. The pre-processing was a situation where we would have to convert nominal values some values for stellar data are in 10 to the power of variables. That complies with a machine learning model, so that has to be converted to floating point values. That's one of our machine learning model.
Alright, so my colleague here will explain some of the process behind this. But after the processing cleaning up has taken place, we train with 6 different models, and then we create extra cluster and voting capabilities based on them, so we stack them together. And here we can see some results where we managed to get an 89% accuracy model based on the data sets. That's with the clean data, 30% of the sample that we didn't train it on. So this is like never before seen data. So our models are fairly integrated together, and they basically perform really well. Yeah, and so time for the demo.
So, as you can see here, we're currently training. As you can see here, we're currently training our own model that we've just started. So we've created our own ML pipeline, going from start to finish, beginning with our standardization. But now we'll go to, thank you. We'll go to our platform, where it basically makes this more accessible to say if you're new to machine learning. Exactly. So this is kind of our entire platform. So you can do, say, what are we setting up? Sorry. Yeah, so you can upload files, say CSV file. You want to upload it to our platform, do some ML, do some classification. So we've multiple features. We basically have. Yeah, so it's basically a nice user interface, but also say if you do have data, we have our Data Explorer, which basically allows you to analyze data. So you can basically get some insights, you can get some charts. If you're into data science, it's really helpful. Sorry, it's just taking a while. We have it deployed. Yeah, so, and then here your classification isn't actually implemented, but this is what it would look like. You pick one of our models, you pop in your CSV, you hold in the background, and then there you go.
That's for data science.
Yes, but we've fledged out our own model, basically end-to-end, entire process.
Yeah, so we trained it from scratch based on the data set we got. We cleaned a lot of it out. We took out, we filled in some missing gaps with like SMOT analysis and some extra, like we make extra feature sets on top of that, like mathematical based on like size, distance, and stuff to improve the model accuracy basically.
Does anyone like minus one stage or features?
Yeah, we had a lot of features or something.
They were rolling. In 1 to 3 seconds, what exactly is what you are at?
So we basically trained.
The untrained person.
Okay, so we basically made a system that you can feed in new data that will tell you if it's an exoplanet or not. And you don't have to do the hard machine learning, being a NASA scientist to understand what's going on.
And you can also train your own.
For the layman person like I am.
Great, thank you.
Next team is Innovate AI.
Hello everyone, I'm Akansha. We are from Innovate AI. So we have come up with a model called AstroMine to discover the exoplanets. So there's been already multiple missions happening to discover the exoplanets. Which the classification is little challenging and not that much reliable. I mean, it takes a lot of time. So we have come up with a model which is a random forest model which processes the data and predicts and produces output. So which prediction is real in does in real time, and it is reliable for the researchers and the scientists to discover more new exoplanets. So next we come with the architecture.
Yeah, hello guys. So for the solution we are going to use this architecture. So what we have done so far is we have taken the NASA dataset and we are going to pre-process it with our machine learning model. And that machine learning model is going to return the result with the accurate data and prediction. So it's so our machine learning model, we have used three datasets, and that three datasets has given us around 88% of accuracy. Okay. So moving forward, I'm going to show you the demo of how we have done it. So this is the interface that we have. What scientists can, not scientists or the user interface, what they can do is they can upload the CSV file and they can see the overall data. Yes, sir. So what user can do is they can basically upload their whole CSV file to get the whole predictions, like, and they can find whether that datasets have some exoplanets or not. So we have already uploaded one. You can see the 31 exoplanets identified with the other datasets. Like any other datasets can be added, and machine learning model is going to do that. And this is the candidates and false candidates. So basically, one is only confirmed in that out of like multiple datasets we have. So candidate basically tells that it is 75% of exoplanet, and this is a false planet that is staying in this either star system. And we also show that all the planets graphs. So you can, so basically it's a playground where you can play like all the light curves and everything. You should see what light curves it is in. And they can see the line graphs, histograms, and this is where we can upload the CSV file. Currently, I think I'm not connected to this database, but it is not connected, but I think we are running that. So we are using free version of the Firebase, so that can handle all the database things.
What differentiates your model here compared to any other ones we've seen today that exist?
Yeah, we are using the dictionary machine learning model. We could have gone for deep learning, but we are using random forest model. And it's quick and faster reliable. So if any of the users, if he wants to see line graph or the data table in the format of the table, then it's better to use a random forest model. So we are using it. So if in the future if they want high level of prediction or more data sets, if we get more data sets, then we can input that and we can train the model still more. And that's awesome.
Did you see the data there in the pre-processing step?
Yeah.
Do you have any idea as to the accuracy of your model compared to?
Yeah, there are other models like if you are using KNN model, then you are going to get high level of accuracy. But if you want a faster, reliable, real-time data, so we are playing with the real-time data set. So when you are playing with the real-time data set, it's better to go with the random forest model. Basically, we are using the random forest for the tabular form. So we are taking the data in the tabular form. So we found that it is the best for the best model for the training for that we are using for the random forest. Yeah. Any other questions? Yeah. Thanks so much.
Thank you. Next thing is going to be found with us.
Right, so I'm just going to be blazing with this because I can't fit 35 pages of model in 3 minutes. So, firstly, we'll talk about vision and mission. So,
So firstly, we're going to pioneer a new stage of space commercialism, and what we're going to do is we're going to industrialize commercial low Earth orbit. So the problem now that we have is that low Earth orbit, there's a lot of commercial plans already set up and some are even in development, but there's no further plan to industrialize it. So why us? What do we bring? So we're bringing a circular space economy. So what we have planned for the last stages of our project, our business plan, will promote that circular space economy, and we want to make it sustainable. And what we have for the revenue models, how we're going to get the money, is by using a phasing system where each phase will dictate our different business objectives. Next. And when we agree that there's a lot of competition outside in commercial legal space, we think that it's better for us to focus on collaboration. And let me preface this is that our challenge for this NASA Space Hackathon is commercializing low Earth orbit. So, go up next, I think is one. Skip past. So, keep going. Yep. Further. Oh, sorry. Alright, so what should be shown here is our AI algorithm model for space debris harvesting for our last phase of the commercial space station in orbit. And
so I built a machine learning model using YOLO-8 and a MobileNet backbone hybrid model based on over 1,000 manually labeled images of space debris. So this machine learning model would detect, identify and classify the different space debris into different categories for in-space manufacturing purposes. And since most of the data is heavily biased and mostly pictures of satellites, the data set is not as accurate as we hope to be, but we'll train on that yet.
Yeah, so that's like a semi-demonstration of what we were trying to get from the last part. I think that should be it for now. If you have any questions.
So just to explain the concept again, you're saying that you're going to go out, look in space at all the debris that's there, identify it, and then how to capitalize on that.
Correct. So, like I said before, we were focusing on a circular space economy. So what we're planning to do is, as we make products in space, we have the byproducts that come out of it as well, and we plan to recycle that. So space debris is basically a byproduct of every activity in space, and by creating a circular space economy, we plan to recycle space debris.
How are you going to recycle it?
We're going to recycle it at the space station.
Okay. Can you bring up there some figures? Can you bring up, maybe go through some of the financial figures that you go through there?
So firstly, we have three phases. First phase will be smaller scale, like what Virus Space and Redwire have in ISS. So we have something like this, where we have to plan out venture capital first before we send out our space stations up in orbit, when we manufacture them on Earth, and then we assemble them in orbit for the first stage of the space station. And then what this pre-phase and phase one kickoff here explains is that here is what we need for venture capital, here is what we need to manufacture the space materials or space modules on Earth, and here's what we need to launch the space modules up onto orbit.
What's the basis for the costing?
A lot of it is theoretical, because I'm a first year student and I get out of my league. But I did go through NASA Action Space, OrbitFab, and a lot of the other companies' market analytics on Statista and other statistics websites, and I just parsed them through some AI models if I needed to get the correct number of correct cost ranges.
Is it because the cost of a payload is more or less eliminated because it's already up there? So is that one of the revenue?
That will be on phase 3. So in phase 3 we will have something called like insight to spacecraft assembly, and you can show this in the live model, right? So the space station itself will have a skeleton-based infrastructure where it can act like a construction site for spacecraft, and basically having the recycled space debris being produced, processed at the space station itself, and constructed there. That means, like you said, launch costs can be mitigated.
Thank you. Next thing is re-explore.
Get ready.
Hi, let me start by introducing myself. I'm Vedanta and this is Mangal, Vidhi, as well as Karnavati. So our problem statement, what we chose was NASA Space Biological Knowledge Engine. So we know that data is everywhere and NASA does a lot of experiments, biological experiments, and they wanted to find a way to summarize all this kind of information for people in this busy world. So to create dynamic dashboards, knowledge graphs, as well as to summarize the entire thing. So we would like to start by introducing our approach towards the problem, that how we thought that we go ahead with that. So I think Padmavati can explain better than that.
Hi everyone. I want to discuss about the approach we used to build our project. First of all, by using the resources provided, we collected data from the NASA's publications and we built a dashboard which is dynamic dashboard, in which if we enter a keyword we can actually see the summaries, knowledge graphs, etc. And after that we created a user interface website which is very easy to use by different people like scientists, managers, students, etc. So I will hand my mic to
So we also have a prototype ready, so I will just go ahead and show you that. And parallelly I'll be explaining about it as well. So we have created a static website, a dynamic website actually. So this is just the prototype. So we have mentioned the first page is just about is just about the introduction. Then we mentioned a little overview about. This is just another introductory phase, just a little interaction with the users. The next is about little bit about the team who has worked on the project. Then the next we have mentioned all the experiments which NASA has worked on and whatever publications are already available. So the last and most important part of the project, which is the dynamic dashboards which we had to create in this challenge. So we had around 608 publications which were present in the resources provided. So using that, we made a dynamic dashboard, and according to the challenge, we had to separate it using making it for scientists, managers, or for general purpose. So we made a pop-up like this. So if we select on any of one, so in this case we selected scientists. So if they just have to give a keyword, and according to that keyword, a dynamic dashboard is created showing how many publications related to that keyword were already done, what were the summaries from those publications, and the year of that journal. So basically, it makes it very easier for the user to read and not just go through the entire publication from top to bottom. Because reading the complete publication takes a lot of effort and not everybody has that time.
And coming to the part where we're dividing it in 3 separate places for scientists, managers and general. So in that case, we've made it in such a way that not every information is shown on all the 3 pages. So in cases like
How does this differ to other search interfaces, say, on databases that already exist?
Okay, so yeah, basically this is more like a summarization. So it's going to give you the entire summary. There are 6 or 8 publications, and we are just searching all of it using just one keyword. So that one keyword is going to search for all the related publications, show you all the visuals against the other keywords. For example, if you select mice, so it's going to show you all the researches that has been done on mice against maybe plants or other things. So that is more like specific, and it's also going to give you a proper summary. If I'm a manager, if I want to invest in a certain experiment the next time, so it's going to give me the proper financial statements and the funding information. If I'm a scientist, it's going to give me a more research-based, more scientific approach towards the problem. So it's, I would say it's personalized for everybody.
Personalized for everybody.
Yeah.
And you determine the different profiles of the information for the different users?
Yeah, so for that we were given this problem statement that we first of all went through a lot of research papers that were there, experiments that were conducted, and after that we also scraped the website. So we mostly use web scraping because it was very difficult for us to create a model where there was not much numerical data. So we mostly use web scraping. So we had to take out all the important keywords from each of it. So I think when we summarized and when we came through the entire thing, we understood what would be the necessity for a manager versus what would be the necessity for a student.
Thank you. Next team is TUS Motorsport.
Hi everyone, we are TUS Motorsports. I'm Dara, this is Nathan, Asher and Daniel. Our goal was to fully recycle all waste plastic on Mars. So it's a space track hack. So in Earth we currently have a way of recycling all types of plastics. In Mars that's not currently there. So traveling to Mars would be a major undertaking for NASA if this is not put in place. So we have to figure a way out to fully remove all waste and turn it into usable types of produce. So the way we're going to do that is circular bioeconomy. So the 3 main products of this, or 3 main assets of this, is anaerobic digestion, pyrolysis, and then chemical recycling. So, out of these, so the inputs with all plastics, all types of waste material produced by humans up there, and then that can turn into biogas, digest, and H2O. With these, you can then produce fuels, and you can produce heat, power, all these types of necessary resources up on Mars, and you only need to use the waste products. So it's trash in, energy out.
So just on Dara's process that he described, Daniel actually has a scaled representation of that. So we took the material data from the NASA database and we fed it into a software called ANSYS Granta Digipack that analysed the materials and gave us the potential energy within those plastics if we were to put them through the process. So now we can look at what plastics will give us the best benefit from the fuels. So as you can see, Loma could be the best. So what we want to do with them recycled materials, there's a lot of fuels, but we want to actually produce products that are consumable on the spaceship. So number one is carbon, which is an output of the process that I described, and that can actually be crystallized and turned into graphite, which is a natural lubricant, which can be used on all equipment across the spacecraft on Mars. Another one is the actual shoes that the astronauts walk in. Because of the abrasive dust that's on Mars, it's going to eventually wear the shoes down, and we can't send 600 pairs of shoes up to space because it's going to cost too much. In fact, to send one sole would cost approximately 20,000 euros, just one. And there's no DPD in space, so it actually takes 7.5 months to send something from Earth. So what we want to do is we want to reuse plastic to produce these soles out of thermoplastics from the process. And if we go on to the next slide. So there's a link there to the GUI for astronauts, and I'd just like to say, going to space, we want our first step to be a sustainable one. Thanks very much.
So you may not be aware of this, but SUSE already has 3D printers on the space station.
Okay.
So that's used for, because of the cost of parts.
Yeah.
So they need something to just replace it there.
Okay.
How would that, even if you don't know about it, how would this kind of integrate with that?
So, for example, with this, there's certain products, 3D printing is fine, but you might have layer separation, it might be strong. For something the Martian might be actually, Martian might walk and it needs to be 100%. It actually takes 15 seconds. We did a full simulation, 15 seconds to produce this shoe on a plastic.
With 3D printing filaments as well, with thermoplastics, you can grind that up and extrude it back into 3D printing filament. So you can recycle 3D printed parts or thermoplastics that you use for packaging machines as well.
Anyone?
What's in there?
So this is just, it would be an interface on the habitat, so you can, actually I'll have to, so you select your input of your waste material, that could be a thermoplastic or a thermosetting plastic. You insert how many kilograms of waste that is. When you hit process, that gives you your total outputs. We talk about rocket fuel, biogas, hydrogen, all sorts of what can be produced, whether it be through the bioreactor or the products.
Can I ask you a question? You have a picture of hands there.
Yep.
The hands or gloves?
Gloves. Yes, that's right.
I was just thinking, are you?
Yeah, I know.
Are they organic?
Well, they're organic, can be put into this as well.
Yeah.
Okay.
So any type of waste can be put into this. And it's broken down into very useful resources.
The biodigester can take all of them and assist in the process.
So, what exactly in a nutshell is it that you're presenting to us here? Is it the idea? Is it the data sets that you're putting into it? Is it a bioreactor or what?
It's everything. It's a whole ecosystem. So if you were to implement this on Mars, you'd then have no waste. You'd be 100% sustainable.
Well, you still need to be bringing your bioreactors and all that kind of stuff up there.
Well, yeah, but
You don't need to bring that.
The cost efficiency, if you saw the SOL is 20,000.
Oh,
if you were to bring everything up, it would pay off.
Thank you guys. Next one is binary plus.
Did you upload it to the OneDrive? It's not here. Can I use my laptop?
So hello everyone, we are Team Baggy Bros and my name is Arush and here's my bro Piyush. So our challenge is will it rain on my parade? Now as you all know in Ireland it rains a lot, right? You always need to check your weather app before going out whether it is suitable to go out or not. So, but instead of checking the weather app, we have come up with a very unique solution which is Forecast IQ. Now here you can actually select the time and the date from where you are checking the weather app, and it's also event specific. So for example, if you're going for a walk, you can select that you're going for walking, or if you're going for a hike, let's say if you're going for a hike at Athlone, let's say. So you can actually check the weather over there, and you can also select the event and the date. So you get the very accurate result according to the latitude and longitude of that place. Now let's see our tech stack. Can you go back? Yeah. So we have used a classic MERN stack application. So we are using MongoDB to store the user login details and the user queries. And we're using Express.js and Node.js for backend and React for frontend. Next slide, please. Yeah. So, so we are actually taking two APIs, which is NASA Power API for historical weather data, and for future weather data, we are using Open Weather API. So what we are doing is we are taking data sets from there, and we are fetching it into a very popular machine learning model, which is random forest. So by doing that, we get much more accurate weather predictions. Now we have used Google authentication for user login, so that the user can log in and see the saved queries for where he has actually saved the weather, the queries, and then we have used Google Maps API for the maps, so he can actually drop down the specific location where he wants to check the weather. Now, so let's look at our web app. So here is our weather app. This is our dashboard. It actually tells you what we actually do. You can plan, we are using the NASA data, you can plan on Google Maps, and you can save your queries, you get smart insights, which is using our machine learning model. So first, let us create a let us go to the sign-in page. Let us get registered ourselves. So the user can create a login for himself. Yeah, so there you go. Now you have logged in with your account. Let me just refresh this. Yeah, so here is our map, and then you can actually, let's say, as I gave an example, for instance, we are going to Rendelog for a hike. So let me search Rendelog. Yeah, and then it drops to the location, which is Rendelog, and then now you can actually type the event which you're planning for. You're going for a hike, so you write hike. Now you select the date range, which is when you're going to plan the hike for. Until 7. You can also specify the time range, so you get the real time weather forecast for that time itself. Now you click on Analyze Weather. So you get the weather results, which is real time. So currently it says that it's 50 degrees Celsius over there and it's cloudy. The humidity is 68%. You get the historical analysis, which is we got from the NASA Power API, which is corporate, and then it also assesses you that it's great for outdoor activities, which means that you can actually go to the top on that day. Yeah. And you Thank you. Yeah.
What kind of benefit do we have of adding in and going for a hike?
So instead of checking the weather app, like you go and check the weather app, here you can actually, it's much more user friendly. So the user knows that it's more event specific, I would say. That if you're going for a walk, so it's just a front end thing. So like the app tells you that yeah, it's good to go for a walk. It's just like a reminder thing. It can remind you on the watch or on the phone that yeah, it's good for a walk or a hike, and you have actually saved that analysis before. So it's good you can go and hike on that day itself. And then we are also using NASA data, which is much more accurate,
and we use the Open Weather Maps API, and we fetch it into the random forest machine learning model, so then it gets a much higher accuracy rate. If we didn't have time constraints, we could have actually gotten much more high prediction rates, up to 95%, but right now it's, as you can see in the app, you get those analysis. So I think you will like that. Thank you.
Nice to turn off Lunar Labs.
Is there a chance you can connect to the big screen?
Hello everyone. We are Lunar Labs, and our project called Simulated Asteroid Impact Effects. Asteroids are very rare, but when they strike, the consequences are catastrophic. Most of the tools nowadays focus on predicting and tracking the asteroid path, but very few of them truly understand the impact of the asteroid.
Next slide, please.
Most likely, that's where our solution comes in. With our simulations, you can put in different asteroid parameters such as speed, density, etc., and launch it anywhere at the map you want to. Our system then calculates the effects of the input and presents them in a scientifically accurate yet entertaining way that gives researchers, educators, and the general public a deeper understanding of the asteroid impacts when it hits.
Okay, yeah, we'll proceed to this demo. I'm sorry for the screen, so we'll do it mostly for judges. So please come here. Yeah, great. So this is a demo of our website. So you can pick any location on the map. From there, you're somewhere about Germany. You pick any location on the map. Then we fetch data from the NASA EDO, which is potential asteroids, which falls stranger to our Earth right now. And then you can tweak some values, for example, density, speed, and radius of the asteroid. And you can also fix the angle of impact. And now we hit launch, kaboom! You have a little animation of the strike. And on the right, you can see we evaluate the cost of evacuation of the people, as well as the food cost for the people for 60 days. We also evaluate some other metrics, like fuel. And on the left, you can see different radiuses. So the first radius is the eardrum rupture, then it's whether the building will collapse, and then some other one which is 99% fatality. So this is all other circles. So over here, you can switch between different views. Now you're on the crater view, so you can see what is the affected area like this. This is asteroid, what is the width of the crater and depth, so it's roughly 4 kilometers, 1 kilometer. Also the yellow area is the area of the earthquake. And as well, we show how the dust will expand in the atmosphere with time. And what's next for our project? Please do the next slide. Next of our project is that we want to add the flood map. What will be the tsunami effect of the asteroid, as well as impact on the climate and the food supply. That's it. Thank you. Did you like the saxophone? Come on, give some cheers for our player.
That Gaussian
function was written by Margdelli for us. That's why we played Godfather team for him.
What separates what you have done from anybody, from any other models?
Yeah, so we want to focus on the, not on the visual orientation, we want to focus what will be the humanitarian results of it and how to mitigate them and actually how to plan. So evaluate the cost, evaluate the flooding area, how to plan the evacuation. It's our main area of focus, and also the effect on the food supply, because a lot of mass can eject and it can cover the earth with dust. So what will be effect on our climate?
So it's predicted results from real-time data sets.
Yeah. So you can pick any parameters of asteroid where you want and the location of where it will drop. Yeah. Okay. All right. Thank you. Thank you very much.
Thank you, guys. So next team is Pizzicato.
Hi. Hello. Hi, we are Pizzicato. Do you know what an robotics major, a UI designer, an AI engineer, and a web developer have in common other than our love for pizza? Next slide. None of us back down from a challenge. Despite having no experience in VR whatsoever, within the last 2 days, we acquired a whole new skill on top of meeting the goals for this hackathon. Our topic was Deep Dive, which is about creating an immersive experience to spread awareness on ocean life. To tell a story about the ocean, we planned to put together an engaging story for all age groups, loosely inspired by our experiences as a kid in planetariums. Here's what we created so far.
So, I think we already talked about the idea. So, what we did was a 3D model, a simulation, for what kind of story we want to tell.
You want to start?
Yeah, I'm just showing you guys this so it makes a little more sense when I show it. So what are we watching? It's a 3D model, it's a simulation of what we want to do. The goal is to be able to explore the ocean floor using the data that's available on NASA's various data sets and things like that. This is a very, very bare bones, very rushed sort of creation. And we don't really have a lot of experience with VR or with building, so it's very, very, very quick. I'll just get back up on stage. Thank you. So, our goal is to create something that is engaging and fun for viewers and like listeners of all ages. We want to create an immersive VR experience because of the lack of resources, because we don't really know how to do it yet. But what we have a story in mind. What's important for us is to tell a story about the oceans, to be more specific about pollution in the oceans. And like, we've got a whole bunch of ideas. This is basically just step one of the idea that we got. We've got the whole thing down. Hopefully with enough time and resources, we should be able to build something bigger in a more game-like format, so that a lot of people can watch and sort of learn from it. We want to have build something that not only is engaging and enriching, but also like useful, educational, and you always come out learn something. So,
you say you want to tell a story about yours. What is the story that you're telling?
okay, so we want to talk about the effect of pollution on the ocean floor, on oceans in general, but like to be more specific on the ocean floor, there's a lot of data available from NASA about the impact of, for example, the impact on coral reefs, on how the temperature, the sea salinity changes, how the sea temperature has changed over the years. So we want to make, all of this is very complex data. It's very difficult for someone who's a layman to understand it, or a child to understand it. So what we are trying to do is to make it into a more palatable form, into a much more simplified form. So we're not taking away the gravity of the situation, we just want it to be a little more accessible to everybody.
In addition, our story also has a hidden purpose. So we are trying to make a campaign let's save our ocean.
We are also focusing a lot on interactive aspects of this simulation, as in certain aspects are interactable, like you can rotate the earth and touch the fish or stuff like that. So this would bring kids more interest from kids, and they would be interested in learning more. And then we would also restrict certain content by ages, if it's a VR thing. Or we would have a generic alternative as well. So that's what's on the roadmap.
So the next thing is rubber duckies.
Yeah, hi everyone. So today we choose the Internet Learns as our challenge for this year. And our team name is the Rubber Duckies. So this is Andrew and my name is Kai. And our objective is to develop an interactive web-based tool that integrates NASA's near-Earth object, APX, and USGS datasets to allow users to explore asteroid impact scenarios. And through an GUI, users can examine asteroid parameters such as name, velocity, and size. And our target audience is scientists. They might use it for research and policymakers, for planning, and public for awareness and learning. Technology we use in this is Python, Java, and data from NASA's API. And due to our time and technical limitations, we couldn't make our initial idea happen. But in future, we hope to transform our GUI into a user-friendly app and to have some real-time alerts. They will send notifications when a meteor or asteroid is approaching Earth, and we will integrate with NASA's API for accurate and up-to-date information. And we hope to educate and inform the public about near-Earth objects. And we might also add some 3D and AR experiences so users can see orbital paths in an immersive environment. Thank you.
So now let us go through the data flow for our system. So first, the user should able to type in input into the Java known as a client side, and when the Java client able to detect the things from the Python, that means is the Python is the server side which have the connection between us under the same network, and yet the Python will take the NASA API from the HTTP to the HTTP and now the Python will show up all the and this is the example for the GUI things that how it works the data flow. And same as well, the user is able to type in the reference ID from NASA, and they're able to pick out the data that what we want and show more information about the asteroid things. And now let's demo.
So it's going to be policymakers, what are they going to use this for? Are they going to be able to use this directly themselves?
Yeah.
Or are they going to rely on data scientists on their behalf to use this?
Well, my thinking for this GUI things, because as we know that GUI is the basic thing for the Android Studio app application. So I hope this application will be low cost and intended to accessible for the public.
Yeah, because policymakers think money. So, you know,
Yeah.
they think about the cost of
But
implications.
prevent the risk and prevent the more consumer the money.
Okay, great, thank you.
Thank you guys. Now it's to moon workers.
So actually, is it connecting to the?
Yeah.
Idea on the cloud. Idea on the cloud. No, just show the information on the laptop. You can hold the laptop and deliver.
Sorry, bring the laptop down.
Good evening, judges. We are moonwalkers, and this is our product Tachyon. So, the problem that NASA scientists face is hundreds of studies on human biology are happening in space, but they are scattered. Scientists spend hours finding what works and what's uncertain and where the gaps are. Right? That's a real problem. And for that, we have built our product Tachyon. And moving on to let's keep this boring PPT aside and let's go on to the presentation. Now, as you can see, this is our user interface. It's deployed on the web, so you can access it with your phone right now if you want to. And let's move on to our USP, which is the Tachyon Buddy. It's multi-agent RAG-powered chatbot. Now, as it's thinking, 7 specialized agents are working together in synchrony across different nodes and getting all the data from these 608 papers in the NASA publication directory. It also has more than 4,000 nodes. So it's skimming through all of that details right now and is gathering all the reasoning information as well so that it becomes interpretable, right? And this is the whole thing. If you want to try it out, you can try it out on your phone. And this is the most relevant table that is being retrieved. We also have a relevant figure that shows bone density is being lost when astronauts are going to Mars and the moon. So we also have a knowledge graph because the problem with AI models is interpretability. AI models are black box in nature inherently, correct? So that's why we also have an interpretability graph. So if you can go through the graph, you know the reasoning traces what the model followed, right? And moving on further, that's our dashboard. You see we have 572 papers in there right now, and this is dynamic. So as NASA has more papers, it ingests those papers and gives you tailored data analysis over those papers. So it has a lot of metrics, and if you go here, you can directly go to the PubMed platform, and this is the RSS feed. So basically, there's a lot of space news around, right? So if you want to go to that space news, you can get it directly on the feed on the website. And the last part is obviously the knowledge graph. It's something that is really creative that we made in the last couple of days. You can go, scientists can look at this, they can see various connections, which experiments are being done, which papers are related to which experiments, is there any particular domain which is not explored, all of these things. So that's about it. And this is the live on web right now. NASA scientists can actually use this now. And the other thing is, we are trying to take this further. So European Space Agency, ISRO, and other space agencies can also collaborate with this so as to facilitate better collaboration. And because space is all about exploration, right? There's no one country that is doing very well, and everyone has to collaborate with that, right? I'm sorry I was a little fast, but I will do justice to my teammates if I didn't show all of their hard work. Thank you so much. If you have any questions.
I have a question. I think that you made this clear that the content that you're using is NASA content.
Yeah.
So it's not like a regular database. It's like a database for this material.
Yeah.
And then you have, it's very similar to Google's connected papers.
Yeah.
Is that what it's doing? So it's subject related and relationships and ontologies and all that. So that's a big difference because I haven't gotten that what you're using is NASA's content rather than just open source content.
Yeah, we are using NASA's content, but that is open source already. That's available in PubMed already, so you can use it now. But we also have more resources, but due to the time and resource limitations, we can only put so many papers in the knowledge base because we have to create the knowledge base from scratch. So it has more than 4,000 nodes, and you're only allowed to have so many nodes when you're using it in the free time and the cloud base, right? Any other questions?
Could we extend it to other sort of databases?
Yeah, this is primarily a graph database, more precisely Neo4j, but any type of non-structured database can be used in this. And right now we are also we are trying to implement vector databases as well, so as to enrich in the retrieving part of it. But due to the time limitations, we didn't go in detail in that.
This is limited just to databases in terms of publications. Is there any possibility for the interrogation of these for the identification of what is new, innovative, and novel?
Yeah, that can be done right now actually. Our app supports that, the web app actually supports that. It also shows which paper came out recently, which paper is novel, which paper is something which is old, right? And obviously when you look at the knowledge graph, it's interpretable, right?
In relation to, for example, patents or patent assessments, what's the difference between this and other modules such as PatSnap or if you're familiar?
Oh, I'm not familiar with PatSnap, but in terms of differentiation, the only thing is we're using 7 specialized agents there to retrieve this content. So everything has a different perspective. Every agent has a different perspective. It is looking at that particular data in seven different views, rather than a small, rather than an LLM which is looking at it with just one view. So it has a incoherent perspective, but this is a much richer and coherent perspective that is tailored to scientists and biologists. Thank you so much.
Thank you guys. We're gonna take another 5 minutes break and then we're gonna go for the last presentations.
We're not starting, right?
All sorted? Fab? All sorted?
Can you call the next team?
Alright guys, thank you for waiting. We are ready to start again. The next team is gonna be the hackers.
Welcome, ladies and gentlemen. Good afternoon. My name is Alessandro Belastai. This is Mekar Center. This is Yulin 1. And then there is Ian Kang, who is sick, unfortunately. He could not make it today. How are we doing? For the past 48 hours, we've been making a project which is about a combination of the overall world and Earth. Earth science based. It's a combination of both. And with the aid of NASA datasets and research, we've been able to design a virtual world which has realize a virtual world which is a we've been made a virtual world which is realistic environment. The simulation starts with a satellite on the Earth, and the satellite orbits around the Earth, and then it zooms it into a water droplet. The water droplet starts the water course, and the water course is able to, with the water droplet, goes with the water cycle, and around it, it goes around the ecosystem, flora, and fauna. During this journey, the user can interact with the environment, study the animals, showcases such as the emperor fish, the cows, and the butterflies. We can also see how climate change impacts those flora and fauna. For example, climate change in the last few years has helped the sea level to rise, and therefore it decreased the fish population. Thanks to the NASA research, we've been able to see that it's not just abstract data, it's happening right now on an everyday life. And we decided to bring this idea because it's unique, and we think that it's good to raise awareness for the future generations. So we're aiming for this project for younger kids and younger generation for the next few ones. We've designed this and we've done test cases and we've run some tests to prove that it's happening right now. And we've also included the inclusiveness of the presentation. We made a selected path for disabled people who cannot move, for example, so they are able to interact with the world around it. Inclusiveness is very important. And we've been able to do this thanks to testing, and we made the text support and the narrative story interaction as long as audio development. Ladies and gentlemen, climate change is happening right now, and thanks to data research, we're able to continue. We make this project and hopefully raise some awareness for the future generation. Thank you for your attention. Yeah, so that's our word, that's our simulation in the curve.
Maximize first, maximize.
So that's the simulation. It can also be done on the VR headset. For people who don't have the VR headset, this is a simulation. There is a river. We've lost the textures of the world, but there was supposed to be trees and data, and that's text boxes to represent information and to deliver it to the users. Is there any question?
Okay, so we're trying to explain the impact of climate change. That's what we're doing here.
Absolutely.
We're educating younger audiences about the impact.
Yeah.
Okay. So is there an education piece then for educators to use this on children's behalf, or is it just for the user?
it will be for the user to interact with the world and explore and see the different climate change and how, for example, it depicts differences of how the fish were once and then how the population is right now. So
Before and after?
yes, the before and after, yes.
I can project into the future what how things will look if we continue the way we
It is a beginning and an end. It begins on the mountain source and then it ends. It does not project to the future, but it shows some differences so you can kind of see how it was before and how it will look in the future.
And you can kind of extrapolate talking about using this with VR sets.
Yes.
So how would that work? I know that's really useful for people who have mobility issues. But would you think about this going into classrooms with students using VR sets?
In the future, there will be definitely more VR sets around, so maybe this can be some interactable lesson that teachers could do, and it might bring the class together. And I believe that it is, it might be used for the future. Yeah.
That's text that's actually coming up as well. Are they seeing that when they're?
Yes, they do see that and this information with the animal on the floor and the fauna and so on.
Thank you so much. Thank you. Next thing is going to be Brilliant Pixels.
That's not the Google Drive. That's just an email.
Hello everyone, we are Team Brilliant Pixels and we build analytics. So our challenge was to utilize the tempo data. Tempo is the satellite data. It measures the tropospherical pollution through the satellite. And after we started with the challenge, we realized that this challenge, the data is both boon and a curse. The boon is that it is a very big data and it is very heavy data and it is very detailed. And the curse is it generates this data every single day, which is very hard to process and it remains underutilized.
Okay. The tempo satellite, in a single day cycle, it generates like a 12 GB of data, which is like a very huge amount of data. So we decided to convert the data into a JSON format. It's like a workable format. So again, it just turned it to a 26 GB data. So here there are products comes into play. Analytics. Analytics merges the tempo data with different sources of files. Like we took the data from for ground sensor data, we took the data from OpenEQ, and for the temperature, that is weather data, we took it from the meteormetrics. Both are from the NASA's websites. This data, when we generated the pipeline, it just reduced the data from 26 GB to 400 MB, 400 to 500 MB, and we just made it into a vector format and just overlaid on the map.
So let's dive into the technical part of it. We have started our system with like heavy, massive data sets, and like I said, where the magic actually happens. So our map, which is really visible on the dashboard, it is really fast and non-distorted form, and it is actually handling a huge amount of data, which was like really not possible with the existing data which we got earlier. And not only that, when I'm talking about non-distortion, so when you zoom in, its maximum zoom level also, it is like crisp data, which is at the means initially it was like a very challenge for us to get those data in platform. And on the left side we see we were also able to generate few stats that is actually from weather data using Google API, and then also from the data generated from our system. Another component which we were able to integrate using unfiltered data, that is REG-based AI Copilot, which is like actually to assist users. So, for example, if I'm giving, let's say I have forgotten my search engine state. So I can ask over here, this is particularly a web chatbot. It's not like any general AI. So if I'm asking like what kind of SEO should I be using, so this will give you as per the weather, and then it will give you some solution on it. So that's what we have written, and you will think that where will the revenue come from. So we have deployed this data into cloud. So from there, like anyone who really needs it can use it by using secure APIs, and that's what like we wanted to monetize our platform. That's all. Thank you so much. So any questions so far, sir?
What is the key differentiator of this compared to any other systems that currently exist?
Actually, the other systems which are in place, they are meant for their specific data. So NASA handles their own data. Our system is, this dashboard is a byproduct of our system, which is the analytics cloud. The analytics cloud can connect to multiple sources, gather data from it, filter it, and display it in real time. Like a single day, in a single day, it would generate 26 GB of data. It collected 26 GB of data and was able to build 1 MB of this high quality data and able to put it here. And another part is when we filter the data which is left over, it's not left unused. That is used to process data model, data forecasting, and it is also used by our AI chatbot. It is stored in a vector database in Supabase, and it is retrieved, and it is a RAG based chatbot, and we can play with the data around.
So you said your biggest challenge was filtering on the data and zoom in on the data. So can you describe how you address that challenge? What did you do?
Yeah. So actually we had collaborated data with different sources. One of the data was from NASA, and we have collaborated with different APIs. Like we have merged many databases together. The NASA database is now also merged with different APIs like weather data and ground sensor. The database which is coming from NASA, it is basically the tropospheric layer. And the problem with NASA was they were not integrated with the sensors, the ground sensors and the weather API. So what we are doing is we are placing weather APIs and ground sensor along with this data, and we are the first one to do this and implement this right now.
Any other questions?
No,
Thanks guys. Next thing is gonna be space conquistadors.
Earth is the cradle of humanity.
but man cannot stay in the cradle forever. A great quote from a famous Russian space visionary, Sun Tzu, probably. Ladies, gentlemen, and esteemed judges, welcome. I'm proud to present to you the future of space habitat design, a modular Lego-like habitat builder. Space habitat design today is a fractured, fragmented mess that uses a myriad of software solutions that are too specialized and complex for the curious young minds of our generation. These tools are often drab and boring. And who wants to look at a screen all day, you know? Com-sci students, am I right? Therefore, NASA has challenged us to create an easy-to-use visual tool that is accessible and contains the functional requirements of a space habitat. The modular design will outline the area of the space, and the modular components can be quickly moved and switched out for any mission that is required. So, how then do we solve this problem?
We created a practical hands-on model that simulates and visualizes a space habitat. Using an Arduino to communicate, we get to simulate a space habitat. Our tool provides a relevant way to understand. Here we've got 2 yellow living modules for, let's say, a 2-person mission. Each one of these yellow living modules require 1 red life support system. The Arduino system detects how many living modules there are, and based on uses 1 requirement for each of them, and has 1 in case there's enough for the crew. When using NASA data, the Arduino calculates the required volume of all the modules and turns off the corresponding LEDs when its requirements have been met. For more information on the data calculated, you can see the serial output. Our solution can help teach curious young minds about space and living conditions. These will positively impact the youth and nourish their growing curiosity about the universe. It can also be used as a visual aid for professionals. With more time, we could develop and expand our solution to have more modules, more space, and more interactivity. We could also develop the solution to have multiple layers, to have the modules communicate seamless with each other, and develop and expand it to be more of a visual and educational aid.
Thank you very much, judges. Any questions?
How would you see yourselves marketing this?
Marketing, excellent question. So, of course, this is entirely open source, so anyone can come in, design these modules. The STL files are all on the GitHub, so you can create your own modules. Of course, we will be hopefully getting funding from schools, universities to further develop this if we were to further market this to children or mostly students or for visual aid purposes. Yes?
This is a really interesting project, and I just wondered if this could work in space, could it work here on Earth? Can we build modular homes with this type of technology?
Absolutely. In fact, I haven't even thought of that. That is a great point. This can be used for space habitat, for one, obviously, and modular home design. You can even use it for simple cupboard organizations. For like each individual module could be for cutlery or for your tools. This can be really expanded to a limitless amount of possibilities, not alone just space.
Just a quick question.
Yeah.
You could also explore maybe like to neighborhoods. So if you have this many houses, then you need this many schools, this many
Absolutely.
etc. But I wanted to ask, do you think that this, if you're looking at children or school or something, you could gamify this? Like I'm thinking Catan.
Exactly. Catan was the biggest inspiration for this. I was looking at the hexagonal modules they slot in, and gamifying this is the main goal essentially. A teacher could come in, write a couple parameters. We need a space habitat for 4 people, and then the students could go in, play around with the modules, see what they can come up with, what they can design for their own school project essentially.
It's not student accommodation.
Yeah. Yeah.
Yeah, like, I know that like there's a lot of games for kids, but games like this that really will require the brain to think, there's not that many. I think the closest game to this would be Parking Lot. If any of you have ever played it, I'm sure most of you have. But this one kind of takes it a step up, it elevates the entire game.
And it even for like early learning, like numeracy and things like that, you need to.
Thank you guys. So the next thing is going to be code or record.
Which one is two? Give me 2 seconds. Press this button.
Sorry, what's the G name again?
Code orbitals.
Code orbitals.
Code orbitals.
Code.
Yeah.
Orbitals. Sorry, I missed it.
Code orbitals.
Yeah, sorry.
Hi everyone, we are code orbitals from UCD, and the challenge that we have faced is from Earth data to action. NASA satellite collects immense amount of data every day about our planet, and this immense amount of data is shared as open source data set. And this data, when you think in perspective of an end user, maybe a parent who lives in Galway, doesn't make any sense to her, doesn't help her to get a local answer. And it's not the lack of the data, it's just the lack of the clarity and personalization, and that's where Nova comes into picture. This is a completely AI-driven platform which helps you to get your personalized suggestions. And let's go for the first demo here. My son wants to play football today at Galway Park. Can I know if the air is good outside?
Yeah, you can come.
My son wants to play football at Galway Park today evening. He is asthmatic. Is it good for him to go outside today? And then you can see the suggestion that it has given out.
Based on the air quality data for Galway Park this evening, the air quality is generally good with an AQI of 37.42. However, considering your son's asthma, there are factors to consider. The wind speed is relatively high at 25.3 kilometers per hour, which could stir up allergens or particulate matter, while PM 2.5 is low at 8.98. The high wind might still pose a risk. It's important to monitor your son for any asthma symptoms and have his reliever medication readily available.
And that was in subject with the individual. Now let's scale up more and see how it works for the professional level. Now we have a government professional who's trying to get more data. And this is where the user input side for the LLM. It takes in, it understands the user perspective, what it wants, and when it extracts the parameters, feeds to our model, and then our model predicts the answers. And now, as in context of the professional level official, we can also view additional data on the dashboard that you can see here, and it suggests what it recommends for the official, and then you can also see additional data here. And then we have also provided an additional advanced dashboard that you can see below. So if you want to dive deep in on data, this is all live data displayed here from the data sets. Any questions?
So this is for just the general public, is it?
Yeah, it's hosted on the GCP, so it's accessible.
So basically it caters to every single individual. It might be a single mock, somebody who's just asking concerned questions, or it might be a person who's very enthusiastic about weather data, or it can also be government policymakers just asking what are the NO2 levels or anything of that sort. So it gives them very complete detailed analysis of all the graphs. And the graphs that you've seen previously, they keep on changing for every use case. So not everybody sees the same graphs. It depends on what you're asking for. It's intelligently driven.
Yeah. What data sets is it? Is it confined to existing data sets such as from NASA, or can it be expandable?
So we've kept it completely open source. So we can, right now we've trained it, since it's a NASA hackathon, so obviously we've trained it using NASA data. But then, so currently it's not only NASA data, we've also introduced NASA data and other data sets as well. So it's completely on us to integrate more data sets also. And this is real time, so we have the data coming in as we speak.
And what next for this project?
Yes, what's next is the main thing. So here in this project, right now, we have targeted certain limited set of parameters or pollutants, let's say. Going further, we will extend it, and then we will also more build upon the technical aspects of it. Right now the model is a very basic level. We would go to higher neural networks, graph-based neural networks and all, building up more context to a personalized user. Any more questions?
Yes. Next thing is terabytes.
PDF file, that's
Before I start, okay, my name is Marcel Sarnecki. I'm from Team Terawatt, and I put a bit of a spin on this challenge. I essentially did will it be windy on my parade, or on this site, and this can be used for a variety of things, especially for the wind industry. So Ireland has world-class wind potential, and they're currently in the transition phase of going from fossil fuel to renewable. And I created a tool that allows to find the optimal location for a wind farm in Ireland. The process is normalization. Right now it's very simple, but in the future it's planned to expand it into more complex algorithms. If you want, I could show you the tool. So here are the locations. Right now it's only offshore, but when I add more layers I can make it so that's onshore and it's quite good. And it also has overlays of all existing wind farms, which for research purposes could be exported. You can use the NASA data that I have built into this and click on a wind farm and export the data for the wind farm and get all wind speeds for that wind farm. Yeah, that's about it. Any questions?
Where did you get your data from?
I used Era 5 data from Planetary Computer. I think the Planetary Computer data is from NASA. So, yeah. And the other data, I used Aerogrid's data and SCI data for wind farms.
And just to check, are you part of the team or are you the team?
I'm the team.
Okay.
Yeah.
Have you shared this data with any likes of SEAI? Is this something you just did today?
This is what I did over the hackathon.
Wow, very good, excellent. Where's the windiest place in our garden? We're all interested to know.
Yeah, that's the windiest spot. It's above Senegal, essentially. Yeah.
One last question. So my question is her question. So you know we have you explored the data that SUS collects from Mount Lucas with the wind farm that's there? It's only about 15 minutes from here.
I'm actually working on a project with Guatemala on the Mount Lucas wind farm.
Okay.
I have the personal data, but it's not, you can't use it publicly.
Okay, all right.
This tool actually would allow you to export the data for any wind farm, and you'd be able to derive the wind generation from the wind speeds that you get. Very useful.
Very useful.
Alright.
Sound basically SCAI will like this.
Yeah?
You sound,
Yeah. Thank you.
Thank you.
Next theme is going to be random accessible memories.
Nothing brought back.
It's corrupt. How can I? You have to download it. Can you download and download? No, not in Google Slides.
Random access memories.
Did it download or not? Repair. Hit repair.
I'm data broke at the moment.
Of course. Is there only?
I can send it on to you if you want 2 seconds from.
Can you come later in the end and you send it to us and present?
Have an USB.
Yeah, present later. I'm saying.
I can if you want, yeah.
Yeah. Can you call the next team?
Alright guys, so the next team is going to be Rolls Royce. We're going to be doing this team at the end.
Just press this button. To change the but it's in OBS right now. No, it's not.
The mic is with you. You can start. Yep, time has started. Time has started.
Hello everyone. We have Team Rolls Royce, named after one of our team members, Roy. So I'm Veronica, this is Roy, this is Nathan and Australia. And we chose the challenge A World Away, hunting for exoplanets with AI. So for this challenge, we created a model that uses data sets, collected data from 3 different satellites, and essentially predicts upon user input whether the data you entered is a confirmed planet, a planetary candidate, or a false positive. So the motivation behind this challenge is that manual classification is slow. So it would be very helpful. Next slide. So yeah, we created an AI-powered web application that utilizes an AI machine learning model. We trained and tested this model using the data sets provided for this challenge. Next slide. Now I'm going to pass you to Hayden to
Do you want me to go through the fast?
Yeah, you can go to the fast.
Alright, so this is the homepage. So first you can input your data. So this is not catered to only scientists, but also like normal users like us. So you can like just put any data that you think that you want to check if it's an exoplanet. So let's say what Drew has is these not like numbers, and it will show like what the result is. So like it's currently for this time frame, 2 days is like kind of short for like you to train a model. But what we use is random, of course, but our future plan is to combine actually more than one model. So let's say like BGM, right? Yeah, and also like expose all different models to make it higher confidence. So 2 days is like not a big not a long time to train a model. So that's why that's the reason for the low confidence. So if it's low confidence, it will put it on the candidate, but it still thinks it is a exoplanet because we actually can verify it through like our database. So if it's an existing database exoplanet, it will show it right down below. And you can see like these are the graphs like it really like show that whether it thinks it's a candidate, confirmed or false positive. And
I just want to stress that this project is very much in development, and also I want to just touch upon some of the difficulties and future improvements. So we did struggle a lot with this project because I think we underestimated how complex it actually is. We could
understanding how complex it is and the challenges that were there, what next for you to circumvent those, to get over those hurdles?
Yeah, so like I said, we would implement more than one model, so to boost the confidence higher, to make the machine learning model accurate, to further predict the results better.
Why did you pick random forest as your method using the model?
Yeah, we actually experimented quite a few, so maybe Roy can talk about it.
Yeah. We actually didn't have that much time, and we just tried it on smaller sample sets, or like we just made smaller subsets and just tested it and just looked through it, and then we realized random forest we could use it for this hackathon. But then in the future, we're definitely exploring other options so that we can improve it, because this isn't how I wanted it to be actually.
So can I just ask your colleague here, what did you mean by complexity, challenge complexity? What kind of things?
Okay, so none of us, well, except Hayden, kind of had experience with using machine learning. So we kind of just chose this challenge because we wanted to experiment with it, and like I personally was very interested in trying to learn how it works and trying it out. So I think we spent a lot of time trying to make the model work, and that kind of like really set us back on everything else because yeah, we just don't have the experience. So if we had more time, I think from now onwards, I think we could definitely improve that. I have lots of ideas to add to the project as well. Thank you.
Thanks, guys. Well, the next theme is going to be Deepuganotes. Sorry for these guys. Deepuganotes. I just forgot about it.
Just press this button. Just the right arrow. Sorry, press the button. Good? No, no, just press the right button. Am I gonna do it? Press the maximize button on the screen. Press the maximize button on the screen. Oh, press the maximize button on the screen.
Hi everyone, I'm Tom, and we're Debuggernauts. NASA takes a lot of photos, from gigabytes to terabytes in size, and people can go online to view them. But the existing user experience is clunky. Seeing this issue, we chose the challenge in Bigging Your Eyes, and our goal is to optimize the user experience when viewing these large images and maps.
So how do we optimize image rendering? We first use tile-based rendering. We use low resolution image preview, and we use our own new product, semi-lazy loading.
So the tile-based rendering involves an algorithm which divides the image into multiple tiles, 128 or 128 pixel tiles, which are rendered in parallel. Each tile is fetched with an API code to the backend based on its linear position upheld by Python.
So for the low resolution image previews, rather than loading the whole image straight away, we load a tiny little image, as you can see here, heavily compressed. It's only about a kilobyte in size compared to this one, which is 50 kilobytes. Which, when you're loading up the website, it's much quicker and you're not sitting around waiting for it to load. Then we also use semi-lazy loading, which we only render the full-size images in the middle on your screen, and then outside the screen we render the previews, which when you're panning around means you're no longer going into just black boxes waiting for it to load. You're getting a rough preview of it, and it doesn't put that much extra pressure on the server side because they're so small. They're less than a kilobyte each. Most of them, the largest ones are 4 kilobytes.
Alright, well done. Let's first have a look at how NASA actually implements this at the moment. When we move around the map, you'll see, at times, you'll see like these small like black chunks appear. This is because at the moment NASA fetches these chunks one by one, which is very inefficient. This usually occurs mostly when you have like poor network or if you're panning extremely fast. So our solution now. This is our improved version. It creates a smoother user experience by instantly rendering low resolution tiles around the visible area. As we pan across the screen, there are unrendered gaps. Those low quality tiles appear immediately, giving the illusion of continuous coverage. This brief placeholder phase gives the server time to load the high resolution tiles, which then seamlessly overlay what's available. This small anything that uses this at the moment? Yes.
It's similar to a thing called lazy loading, which just renders what's on screen, but we've extended it to have the bit extra in the previews.
Sorry, can you just clarify the overlaying of the rendering?
Okay, so what happens? When we move around it, we have low resolution tiles appearing. Then we wait. The bottleneck is that the server sends a tile in, but because the 4 kilobyte are so fast to place, they appear instantly. And then once we fetch the high resolution one, it simply appears on the screen and it just looks flawless.
Perfect. And do you need sort of very powerful hardware to?
Not at all, no, because once it's sent and we pan away, it actually deletes behind it. So you don't really need to store that much information on.
And even at that, the images are pretty small in themselves, like 50 kilobytes, which, okay, there's a few 50 kilobyte images stitched together. It still isn't taking up a ton of RAM.
If we have a look here, these are actually in inspect out of what we're sending. The small ones, they seem to be at most about 2.5 kilobytes here. The big images, they go from 10 to 15 kilobytes. So this would be a huge performance increase, yes.
What interface are you using to show us that image there? As you're scrolling, what's the ID?
This?
Yeah, the image. As you're showing us that they're scrolling through, what are you using?
This is just developer console on Google. It just shows what we're fetching from the API calls from the backend.
So the next team is Sultan.
Hi everyone, my name is Mohammed Sultan. I'm a recent software engineering graduate. Today I'll be presenting my project, Space Biology Knowledge Engine Library. So, what is the problem? The current problem is that the space biology findings, the publications are very long. So if I'm a student or I'm a researcher, and I want to save time to just see the overview, the introduction on the research, the findings and the conclusions really quickly. Or let's say I'm an investor and I'd like to invest in projects related to that field. It's too time consuming to go through the details, or I can't find the information. So I'm trying to put it all in one library where you can access any project quickly. You search by keyword or by subject, basically, by name. So, as I've mentioned, that's the SBKL, and it will also have AI insights. So you will have a dedicated chatbot. At the moment, it can be used. You can use an API from OpenAI API or such. And in the future, you can build a dedicated language model to basically train on these different researchers and ask specific questions, basically. So this is the front end overview, as you can see. I went with a very simple design for time's sake and for simplicity, so it doesn't overly take time for someone to find the information they're looking for. So you have the search bar right there, so you can directly search and then show you the results for the research you're looking for, the publications you're looking for. And then you have the library there. I'll show you an example actually. The demo. Scroll through. You can scroll through and you can go by letters. The door on the side, if you're looking for something specific.
Do you already know about?
And you can click view details,
The tags.
and such. And the details for each one. So I'll just continue with the slide and I'll go back to it. So yeah. And then the next part will be the publication view. So I'll show you that now. And it basically has the overview of each research. Once you search for it, a publication for it, downloads for the full I'll show you one last thing before I do ask questions. This is the back-end details. I couldn't show you, but this is the details of what it would do and the status and the roadmap as well. So, any questions?
Yeah, what sets it apart from databases that already exist for these publications?
The databases that currently exist, they have all the information. It's a lot. If I'm a student, for example, who's interested, or a peer, or I'm a researcher who's looking for something specific, it will take me too much time to go through pages and pages of publications. So I want to search specifically for what I want, save time. I'm an investor as well. I want to know, I'm looking for something related to experiments in microorganisms. I search for that and find the information I want. Any other questions?
What next for this project?
What's next is to build the back end, have it fully implemented, so it's a much larger scale. Add more information. This now is only using the NASA dataset, but you can add much more. Also, I have ideas of adding dashboards for each person, where they can add their own research. And that means me as a researcher, I can have my publications available to anybody who's looking, whether it's an investor or other peers. You can easily find my research, find related publications and that help enhance contributions and investment results. Any more questions? Thank you so much.
So next team is Compilers United.
So just press this button.
So good afternoon everyone. We are Compilers United and we have created a habitat named Cosmic Pods. So designing sustainable habitats in space is complex, balancing life support, power, storage and comfort within limited volume or simulator empowers engineers, students and designers to visualize and experiment with layout interactively instead of relying on static blueprints. So we have created a simulator that will allow you to take palettes from our imposed palettes that you can put on the grid layout and you can review it in the 3D preview, and it will give you a report based on your score that how much reliable your space pod or the cosmic pod that you have built is in the space or the whatever mission we are planning to do. So the scoring system that we have Imposed is the scoring system measures how efficiently users design their space habitat by evaluating pod arrangement, distance and functional balance. Higher scores reflect optimized living conditions, effective energy use and empowered mission safety, encouraging smart human-centered design decisions. So now I would like to give you the demo of the application that we have created. And it will produce like a PDF for you that you can see in the end to get you more detailed scores and everything. You can also take snapshots of the 3D preview that you have created. The future goals that would be of this application is that we would like to take it to the Unity platform, and we would like to create more enhanced version of this because it is just like a 3D model that you can see.
You can drop whatever ones, like whatever needs you want in your pods. Like I need a cargo room, I need a sleeping pod, I need exercise room. So you can like you do the grade according to you, and you can see the 3D room. If you want to
and we have also created a emergency evacuation system in that, so you can try that if you want to visualize or see that if there is a fire outbreak, what is the safest area to escape, and what is the timing that you have. The oxygen will be depleting in real time, and you will be able to find out the real time that you have left to escape the pod.
Anything will happen like that. And in real time, you can see the oxygen is dropping and power is also getting dropped because of the fire outbreak. If there is the hull breach is there, so you will get that like evacuation via exit is the safer zone. So follow the safer zone and you will be evacuated. And in this scenario, oxygen is dropping only in hull station. And if you just got evacuated, just click on the evacuated button and it will be say evacuation successful happened. This is our prototype.
So any questions?
Any questions?
Who is this designed for? Who would use it?
Is this for real? This is for real engineers, right?
Yes.
Oh, it is. Okay.
This is like we would like to impose it to the real engineers, but we will like to open source it and make it for the students also that want to engage in this field and want to try what is this pods and everything, and it can be used in many missions that we are planning in future.
So you can plan pods according to you, like in which use you want. If you want it for the medical support, so you can design your pods according to that, and you will get the score also. Like I'll show you that also. So I was designing the pod for this, and I just downloaded the score report. So one score report will be generated, and in this score report you will see the score for this pod will be 90. Only two structure, the 3D print is also there, your score is also there, and what is the dimension for that, everything will be written here. So all the designing structure of that pod will be downloaded here using the download report button.
The next thing is ice tricks. Ace tricks.
Excuse me, sorry. You have to say start. The timer will start, and then you can start with the session.
What's the name? Farm champions. Like you have to change this one. What percentage? You can.
Start the time. Yeah, it's already.
Hello, everyone. Good afternoon. So, just a minute. So, my name is Mansoor, and I am from the team Starix, currently studying the master program here. So, the challenge that I was given was farm navigation. So, we have to build a simulation app that do two main things. One is the education of the farmers, and second is to harness them with technologies. So what I saw was farmers are using TikToks and they're making some of the content. That means they have access to technology, but they don't know how to utilize them and gain the maximum out of it. So this POC refers to that. So this is the main problem: the unpredictable waters, one duration, and limited access to the tools. Last one I discussed about, do they have something on that? So we have to move on of that. Yeah, just. So the vision was to empowering farmers with the AI data-driven tools. So yeah, in my app you can see the data here. It's the NASA data used, the ANOVA one and Earth space. So we use the data, and here the trends are really easy to be read by anyone, especially for the farmers, the people who you think you don't know. So that's especially for them. So the main task for me is to make the things easy. So there is a lot of, I can make heat maps and everything like that, but the main thing was to just make it relevant to a layman. So that was the best, the challenging part. So yeah, so we have added the learning ecosystem, and that includes the quizzes. So the quizzes is related to the soil we have. So we take that by location. And the last is rewarding. So we have rewarding so that we have to have something to that could be a driving force for the farmer. So that's a reward. You attain the good, what you can say, good decisions, and on that you calculate with the points and after all the rewards. So that's the main thing. I added one more feature of the photos, that you upload a photo of the crop. It takes to the Google Gemini 2.5 Pro API. That gives you the result that it's good to go. You can take the decisions, and as you take the good decisions, the good point score increases, and so far your reward. So that's the main thing. That was the problem, and that's the solution. That's all from my side. Thank you very much. Yeah, it's already there. So yeah, this is the thing. Here you can take the action, like you can just go here, farming into the action, a magnitude or something like that. And after that, if you run the simulation, so that will give you the results. It will give you a value, it will give you, because this is the main thing, the field yield is the main thing. We're going to get the maximum gain out of that, using the previous data of the soil and this. So that is the time analysis, that is the previous status of the soil. It was the stress in the recovery, the health, and recovery. So that was the main thing over here. Yeah, you can ask whatever you want.
How did you get the correlation between the soil was stressed versus not stressed?
Okay, so for that we have formulas for that. And I have documented all of them. I will memorize that.
Right.
So we have data, and for the correlation we use formula to create stress and non-stress and everything like that. Not very effective one, but like the idea is correct. Like we have the formula to be in that.
What data sets are you using for this, or is it real-time feeding, or?
Here are 4 NASA datasets. 2 were like very hard to remember, so I was just concerning about the field, and the 2 were like NASA Earth Space and NASA ANOVA. And one is like SKVD for the soil irrigation thing. Yeah. Anything else?
What next for this?
Yeah, what next? I'm planning to go take it to the next level by adding the satellite thing. So we have to control the carbon emission. That is also there on the NASA data sets. We have to control emission of the carbon, and I discussed with the mentor as well. So yeah, we're about to do that in some day.
Why that's the phone?
No, because of the time and
but
it's possible. Yeah, it's cross-platform. So anything else?
Is there anything
anything current that is comparable to this? How unique is what you wrote?
I found some of the papers researchers are doing, but like in everything here in the one place, I haven't seen so far. There's something that only doing the photo thing, the AI thing. They take the crop picture and they'll do the AI thing, and very extensively maybe, but not everything compiled with the reward system, because reward system I found the best thing to take farmers ahead, because if there is no reward, no one will buy this.
Next thing is cipher plan.
Cyberpunks can you just plug into this? Just need just let me check the PPT again. Wait. His name is Asteroid Impact.
The presentation name.
Yeah. Can you just open the web app link? I don't need that. I just need the web app. Yeah, just open it. I can't. Okay.
Good afternoon guys, I'm Borisha and I'm excited to share you with my web app that is Asteroid Impact Simulator. So imagine this. What if you could see into the skies and predict where an asteroid might strike our planet if it happens? So what if interactive math, NASA's real data and intuitive visuals helps us understand the threat, not just talk about it? Okay. So for that, I created this. So introducing Asteroid Impact. It's a web app that combines live NASA new data with an interactive Earth visualization. Users can actually explore upcoming near-Earth objects, simulate impacts, and deepen their understanding of celestial threat. Note, this is just an educational system, not an emergency alert system. So, why did I build this? So every year, astronomers discover dozens of near-Earth objects, asteroids and comets, whose orbits bring them close to Earth. While most pose no danger, a few do cross orbits in ways that warrant attention. For educators, students, and curious minds, the data is out there, but often buried in technical formats, NASA ideas, or niche databases. So, what does it do? Let me show you. So it pulls live or recent new data from NASA Open Areas. So it plots objects on a globe or map interface. So it lets user click and view. So suppose the green are for non-hazardous ones and the red are for hazardous ones. So let's take a hazardous one. So if you just click on this hazardous one, so it will just zoom into it and we just tap into it. It will create the impact area. Okay, sorry. So it will just create the impact area and show that most of the impact will be happening there. So yeah. So in short, it bridges between raw scientific data and visual and exploratory learning. So yeah. We can also run simulation shows that happens if object impacted with energy or approximate effects will it be there. So I've sorted this by object impact size and also calculated the impact probability of these near-Earth objects. And as mentioned by NASA, if it's more than 3%, as you can see right here, if it's more than 3%, it is shown as hazardous, and if it's less than 6%, it's not hazardous. So this demo illustrates how users move from curiosity to understanding in a few seconds. So what benefits? Like who will be using this? So educators and scientists. Like it is just a Netlify app. Anyone can just open it and see. Like right now, it's in just live data. And also like amateur astronomers, like museums, science community researchers for light use, they can always implement this and they can always use this. Okay. So any questions?
So does the original map that you showed us with the green dots on it, those are all of the...
Yes, like I just wanna represent it, like it is for the next 7 days. Like there's a probability of next 7 days of all these points like asteroids striking. So I know it's scary, but no. Like the probabilities are very low. So most probably it won't strike. So but yeah, there's a percentage chance of that. So
my future planning for this will be like Netlify just provided me with a very small amount of data, like space. So I just took the data for the next 7 days. So so I also calculated the average date like from which it might strike. So my probability is like I can also calculate the second, and also I want to increase it to a month or a year, and so that I can visualize this, and yeah, that it is. So I'm just starting the rotation. It looks cool to me. Yeah. So any questions?
So sorry, were you just saying that you could set that view to be like, if that's 7 days, but you can set it to be
Yes,
a month?
like I wanted, like I'm just a lonely guy, so I wanted to create a dashboard of it, like to for certain dates. But yeah, all these data like it is for the next 7 days. So these are all next 7 days. So the reds are for hazardous one. I'm sorry, my chat just got over. So the reds are for hazardous one, and the greens are for non-hazardous ones.
I was just thinking if you looked at it, that was all red now.
So good, yeah, that's a concern. That's a concern.
Yeah.
The next team will be Caesar.
Just press the right button.
Hello everyone. Our topic is the Shannon polls, forecasting floodplain dynamics. So we're forecasting floodplain dynamics with SAR. For the challenge, we chose through the radar looking glass, revealing Earth processes with SAR. In Alice in Wonderland, like Mark Harris said, she believes in impossibilities. So SAR helps us see the invisible. And that's where we got our name from, CSAR. Our motivation started because one of our teammates had originally done a study on the Dublin Bay, but he ran into some limitations because the Shannon River was flooded. And then this topic gave us an idea to actually use SAR to see the river more vividly. As we can see here, this is using the Landsat satellite. So we can see that we cannot clearly see the river at the side. But over here, using the Sentinel-1, we can see the river very much clearly. Our approach for this study is that we're using the Sentinel-1 dual polarization C-band. So we have the VV and we have the VH. The VV is the vertical transmitter, while is the vertical transmitter and the vertical receiver, while the VH is the vertical transmitter and the horizontal receiver. So basically we're trying to compare when there is flood and when there isn't flood. We can see that there are no floodplains on the far right hand. And here we can see the floodplains. So we can see that the volume of the river has increased, showing that there has been a flooding in Shannon. This is a video showing it. So at this side we can see that the volume has increased, and here we can see that it's a bit reduced. So there's no flood here, while there's flood there. In order to increase the efficiency, we decided to ground truth. So we're connecting the SIM800 to an ESP32, which will connect to our sensors, and then we use ground truthing. So basically we put this in the 12 major floodplains in the Shannon River. And that is it over there. Do you have any questions?
What exactly does the device do? What does it show you?
Okay. Hi. Alright. So what it does is that you have satellite data. It's showing you things on the ground from SAR, but you have to ground truth. Because whatever data is sending to you might have errors in it. That's the problem. So you have to plant sensors in different locations. For example, there are 12 floodplains in Ireland along the River Shannon. If you want to know how fast the flood is going to come, you look at the rate at which each of those sensors are equipped. So that sends it to the central server or to the satellite in the case there is no satellite. So we have an iridium sensor here that sends it to an iridium satellite and makes that happen.
That's really helpful.
Thank you. Any more questions?
Yeah, is this being shared or demoed, or is that the plan?
Okay, the plan is we hope to talk to ESA, European Space Agency, and they will help us to continue the research so that we could stop floods in time, because with neural networks, we could be able to determine the pattern of flooding. And from there, we could determine how soon the flood might hit and which brain is likely to be affected first. So we can put in mitigation aspect. Also for insurance, if you want to buy it, so your insurance goes up. Yeah.
So you're using real-time measured data plus also data sets?
It would be nice if it was real time. The issue is that the SAR, the Sentinel-1 satellite hosting the SAR Aperture, travels every 90 minutes for every between 6 days. So there's a lag there. It's not real time, but in terms of satellite, it's real time.
So what's the sensor actually measuring?
So the sensor is multifaceted. So there are many ways to check if a storm is coming. The water level is one, pressure is one. When a storm is coming, pressure dips. So with the pressure dipping, with water level rising, we could know that a storm is in that location and quickly do something about that.
Have you ever proof of concept of it like this?
We have a proof of concept. Fortunately, I'm a researcher. I was the one that researched the dolphin day. I couldn't see anything because the cloud was way too much. And then I learned the lesson that I have to use the SAR aperture next time, which sees through cloud and the darkness. Yes.
So the last theme is going to be random accessible memories.
We don't have this time.
Hello everybody, how are we all getting on? I hope we're all not too sleepy. So, we're going to run through our Meet Your Madness challenge here. We are random access memory, so think that punk fans in the crowd we just here. I'm Carl, this here is Evan, Ava, Sam and Jack. And we decided to do a little spin on the Meet Your Madness challenge by creating it in VR. Now, some of you who have developed in VR probably wondering why we were mad enough to do it in VR in the first place, since we have very little experience with it. But the way we went about it was, we feel like the impact of stuff like this for especially STEM children, there's not a lot of industry there for keeping them engaged and having that sort of real immersion that you get now with these sort of projects. So we went about kind of pulling the NASA API for the close orbit positions, and what it does now is it actually pulls that data and sticks it straight into the game itself. So you can see here the example, he's going through here, 2025 ones, 2021, and they are very small because they're trying to be a 1 to 100 scale. So let's bring it back home and throw that here to see what would have happened if we weren't so lucky now to have it kind of be a near miss orbit. And you can see this is the person who's not a very good thrower. So, how is it for accessibility?
The way this works is kind of very simple enough. Is this is updated from everything from today and 2 days from the future. So this is going to be constantly kind of pulling new data and new asteroids. They're going to keep it always fresh, always different. Now, we kind of have a simulation here of what the damage would be like, but to be honest, we've ignored atmospheric conditions for this example because I'm no physicist, and in 3 days of working, I decided that we don't have atmosphere anymore, which was easier to deal with. Now, so, I'm just trying to think of myself. Yes. So, the way it works is with an asset API, it pulls in all the data such as the estimated size, the estimated velocity, the estimated trajectory path, and we're using all that to kind of populate our game with this. And one of the things I like to do as well here is it actually tries to put it, because it actually feeds in the close, where it was closest approach as well. So it tries its best to kind of get it to an accurate-ish position from where the sun is. Obviously it's a 1 to 100 scale, because I don't think anyone here has 400 vision to see the Earth a few million miles away. And I think anything else on top of head? Happy enough? Yeah?
Thanks, lads.
Any questions?
So this is for kids, right?
We're going to open to be a case of more aimed towards kind of like kids, like younger, maybe 12, 14-year-olds. Like in particular, there's actually downtown at Athlone, there's a Elevate, I think it's the name of the place. They have a nice little VR room in there, and it'd be great to see stuff like this where maybe on a school trip they could go in and actually see the kind of, you know, getting kind of back into learning about asteroids, back into kind of space observation and that sort of lost art.
So we're tailoring the amount of information that they get from the catastrophe. So for younger kids, we're not telling them, you know, it will wipe out the population, you'll fight for the living day. You know, and is that in the back of your mind that you're obviously tailoring it age-wise?
The way we're getting around that is we're just saying the megatons of explosive. Because obviously if you go about saying, now we did originally have a total death count in, and we're like, that's a bit great, we'll just say megatons. So that's an easy way to kind of go out of that, doing it that way now.
I think the older ones will see through that, but anyway.
At that age, I think they'd be looking up themselves as well, so you kind of carried away with that.
So they're just getting an experience of firing at the Earth and the destructive capability of it.
Yeah, and the fun thing is all of these asteroids here, you can Google them on your phones if you want. They're all real ones you can pull data for right now, so it's nice to kind of have that realism as well, where they can go and research, oh, this one done, so where is this one, what does it look like? It's kind of opening that door again to like experiment with it.
That's what was going to be my next question. So, like, that's kind of one-dimensional. We're firing at the Earth and it tells us this, like, but what else are they learning? Like, have they other opportunities to learn other things in the process of considering this?
No, good point actually. What we'd like to do now to get more data, it'd be great to kind of get data such as like what the meteor compositions are, what their weights are like, what their speed paths are like, where are they coming from? I know one of the information that's said is if it's a century object, where it's going to eventually come back into the system. Maybe the idea would be if they found one they really liked for some reason, well, I'm not going to question it, they'd be able to see with a telescope even when it comes back around. It kind of opens that door again, if you get what I mean. I think yourself had a question as well.
Yeah, it kind of follows up from that. I mean, I was just thinking in terms of like schools and stuff, if you had ideas like league tables and like, you know, they could name a meteorite after their school or something like that. You know, like, because we run like the National Lego League here, and one of the things that's great is the competition. So between the different schools and all that, and a lot of that is the cyclical nature of it. If I build it, what does it happen to it? And so if you consider things like that, or
Something like that actually sounds a little good idea now, to be honest. Even something in case of, I'd love to see an option even for add their own custom asteroids, give the children to draw their own little dinosaur-shaped asteroid for a dinosaur, we'll say, and let them have it's kind of kept simple enough that it's easy to implement stuff like this without it completely blown out of scope.
it's like fun.
Thanks, sir.
Alright, thanks everybody. Now we're going to need some time to our judges to allocate and choose the winners, and we are going to be back in 3 minutes. Thank you.
Hello, all audible, right? First of all, it's 7:34. We were supposed to finish at 6. I'm sorry. Okay, you guys did a really good job. There were 40 teams. Last year we had 24 teams present, so it's a massive jump in the number. We did not expect that, and that just made it tough for the judges to decide and come to a conclusion. So it was tough competition, and we have our results coming up. So I'll keep it quick because I know some of you have to travel down to a different city and you have limited travel options. So I'll run down this particular slide, which is supposed to be the closing ceremony slide. I had a lot of things to discuss, but I'll be very fast. Just to summarize, we had 288 registrations overall. 18 people were in waiting list. So, out of the 270 people, 210 turned up despite that storm, and all of you 210 people, I really find it. I remember the names of most of you now, and it's like it feels like a family, sort of. I don't want to cringe myself out, but it feels like we spent a long time together, and it's just unbelievable. So 210 people checked in on the Friday, and out of them, 50 teams were formed. So 50 teams overall were there at this event. Out of these 50 teams, 40 teams survived this morning, and we had 40 teams present. So we have the top 6 which we'll announce today, as opposed to just 3 prizes. And out of those top 6, 3 will go to the next level, which is the global nomination process. That will be announced on Wednesday. The top 3 which go, but we'll be announcing the top 3 which the judges chose, and those will mostly be the global nominations. So there's a source code review process which takes place normally, and if there are inconsistencies observed, then the 4th gets bumped up to the next spot. But in all honesty, top 3 over here did a massive great job, and yeah, we'll be announcing them pretty soon. 3 global nominees to go. And there was a side quest at this event. So there were 18 problem statements which were released by NASA. These 50 teams worked on those 18 problem statements, made a lot of solutions, built websites, apps, a lot of different items and projects. But there was a side quest which TUS Works sponsored, that was building problem statements for a future event, and that was in the Shannon region. And so yeah, local challenge, the Shannon Studio. So we are going to announce the first prize, not the first prize. So these are the top 10, and we'll call them together because these are top 10 created problem statements which were chosen by a separate set of judges this morning. That was on the local challenge. So I'm going to announce the results for local challenge, the Shannon Studio, and I'll request Pedder to come on the stage to present this prize. So I'll be announcing 10 individuals. This one was not a team-based challenge, it was from all of you individually, whoever got some time besides your global project to put in some efforts towards creating this problem statement. And the top 10, I'll call them out?
Yeah.
Perfect. There's no excitement, guys. No. Okay, so the local challenge winners in Hackathon Side Quest, the Shannon Studio, are Ty Dowdhall, Daniel Constantini, Kathy Brown, Tyler Brady, Alex Lowe, Payal Vaswani, Bart Rohan, and Jarek Cruz. Can you all come to the stage and collect your prize? And all of them win 250 euros each, and that's sponsored by TUS Works as well. So,
just please, many.
Joyce, can we have a photo?
Yeah, they're already there.
Perfect.
Sir, can I have a photo? Oh, they're taking a photo over there. No?
Photographer right there.
So, yeah.
All good?
Thank you.
You never know, some of you might come back. So, again, thank you so much, Pedder, and all the 10 winners. If any of them were not here, they might have gone to their respective cities because of travel options. We'll contact them by tonight and inform them of this prize. Okay, so moving on, we have a special mention prize for our top campus ambassador. I'm not sure if he's here around. He is. Okay. So Liam, if you come down to the stage. Liam from UCD got 21 registrations from UCD. So 21 students travelled from UCD and Liam represented NASA Space Apps on his campus. Thank you so much, Liam, for the efforts. Thanks, Liam. So, moving on, we are going to announce 3 teams one by one, and these are not in particular order as of now, but these are the top 6 teams, not the top 3, the top 6, so you can understand. These are the teams who might get bumped up to the top 3 if the source code review finds some issue in the top 3. I hope that doesn't happen, but in all honesty, these top 6 teams deserved equally. I would not share details, but when I was listening to judges, it was feeling like it was just a tough competition overall. And I first of all respect the judges, how they came to this discussion, and the discussion which comprised of so many factors, so many different sectors, different challenges, and in all honesty, they did a lot of effort to come to this conclusion. And thank you so much to all the judges. If Alan, if I can have you over here. So, Austin Coffee, I'm going to announce the result for top 6, and you'll be presenting them with top 6 first. 4, 5, 6. 4, 5, 6. Yeah. Cool. So, just getting ready with some of the goodies which you might get. Okay. So, one of the teams in the top 6 for Athlone 2025 are TUS Team Motorsports. Come on the stage. So Team TUS Motorsports, you get 250 euros, and
Calm down. Calm down.
6 of these, right? 4 of these.
Yeah.
We have for each member they. You don't need to share the.
It's just a placeholder.
Yeah. So just according to your sizes, you can collect these goodies from us. And Engineers Ireland was one of our partners who were giving away some of the goodies. Great job on the project, and thank you so much, Austin. Okay, so one more team for our special mention in the top 6 is Team Terawatt. Single person team. One man army. When he said he's the team, he meant it. Great one, Marcel. Thank you, Austin. So we'll have one or more judges. Yeah. So Jane, if you could join us, thank you. So the last special mention in the top 6 for Athlone 2025 is Team Astronauts.
Thank you.
The photo over there. So can you?
That was enough.
Okay, okay. All good? Joey, got the photo? Perfect. Thank you. Thanks, Jay. Thanks. Is there you all have all the hats here?
Yeah.
Can you give one to Jay?
Sure. You always have to have them.
Okay, so that was good. Thank you so much, judges. So the next up is the third prize for NASA Space Apps Challenge Athlone, also known as Hackathon 2025. And any guesses? Any guesses? Can we have Claire and Julian, both of you, to present this prize? Okay, but no guesses. I didn't hear any guesses.
It's Jane.
Okay, I think I'm making you wait too much. You'll get impatient. Don't kill me, please. So, third prize for NASA Space Apps Challenge Athlone 2025 is and goes to Team Devaganok. You can come to the stage. So, there are some in-house 3D printed medals for the top three. You get a bronze medal, you get 750 euros as a cash prize, and there are some cool hoodies and cap and merchandise as well.
Congratulations. Well done. Great
I'd like to take that. I like this number. No, we're like on the floor about that. Do you know?
Thank you. So, if I could ask John to join us and Austin as well, if you can. Okay. So, the next prize is for the second prize. And second prize, NASA Space Apps Challenge Athlone 2025 goes to Team Dilly Dally. So they win 1,500 euros as a cash prize and really cool silver medals, 3D printed, and a cap and a hoodie. Congratulations, Dilly Dally.
Thank you so much, thank you.
We're shaking there.
Thank you so much, John, Austin, and Dilly Dally. Okay, now we are talking. Last moment of truth. The winner, the first prize, the top prize for NASA Space Apps Challenge Athlone 2025. Can I call Shane and James to join us on the stage? Okay, so the first prize for NASA Space Apps Challenge Athlone in 2025 goes to Team Caesar. Gold. So they get gold, 3D printed gold medals. There were no marks for costume, just saying, but they got first prize.
After the next to come back, so that I can get go.
Thank you so much, James and Shane and Team Caesar. So just a quick announcement, all the winners, please stay back for a quick bit and you'll get your choice of sizes in the hoodies and all the hoodies. So all the top 6 get hoodies of different colors and just stay back so we can give that out to you. So just to close out, we recapped a lot of statistics and we announced all of the prizes. We had a top 10 for the local challenge and the top 6 for the global challenge. So 3 teams are going to go ahead as global nominees from all of our teams over here. Just some next steps. You need to still submit your project on the NASA portal. So all of you over here will get a certificate from NASA only if you submit your projects on the portal. That means submitting your GitHub link and writing the write-up which they need. So you need to go to the team page, click the edit button, submit it out and press the enter button. So that's it, and you'll get your automatic certificate from NASA that very moment. So that you can put it up on LinkedIn and that goes on your resume, and it's the main thing to have. And not just for winners over here, I think all the other people, I can vouch for you that you had a great experience because I know what was going on over here. You put in a lot of effort, there were a lot of iterations in the projects, and it is something to take away from this event. And yeah, thank you so much for that. I'll call Austin to give a closing note over here, and we'll be sending a feedback forms in the evening so that you can tell us where we went wrong, that it doesn't happen again. Thank you.
Well, thank you very much indeed. And my gosh, what a weekend of creativity, teamwork and innovation was held here at TUS. I mean, congratulations to every one of you. And on behalf of the Technological University of the Shannon, I really want to congratulate again every participant, mentor and volunteer who have been around to make this year's NASA International Space Apps Challenge such an inspiring success. Well done again to everybody here. Over the last 48 hours, you have shown the true power of real open data and imagination, and how dreams can be made reality through perseverance and keeping and putting your mind to it. You have tackled global challenges from earth science to space exploration using creativity, science and collaboration. This is what NASA envisioned. This is what they envisioned when they opened its data to the world, where people everywhere working together for the benefit of everyone. At the Technological University of the Shannon, at TUS, we are proud to host events that turn ideas and dreams into real impact. What you have achieved here reflects the spirit of our university here applied learning, innovation, and sustainability through action. To our judges, and again to our sponsors, and to our volunteers and leaders here, thank you for your time and for your expertise. To our local winners, well done. Cogart Chisliv. The best of luck to your projects as you move forward to the global elements of the judging. And to everyone, remember, this is just the beginning. The friendships that were mentioned here, the skills that you actually have encapsulated by working with each other and with networking, this is what will drive and build a real and dynamic and positive future for all of you. This can grow into something extraordinary. And this weekend, this last 48 hours, you clearly have demonstrated us. As NASA reminds us, when we solve problems in space, we make life better on Earth. So keep building, keep exploring, and above all, keep looking up. Thank you very much.
Thank you, Austin. So we wouldn't hold you enough longer for this, but one last photograph as a team over here. So if both the sides can come inside over there, behind these benches.
We already took one.
Yeah.
We already took one.
The whole people.
No.
With the judges.
Yeah.
With the judges. Yeah.
So the organizing team come in first.
I just got to know that you already clicked the photo, but we need one with the judges over here. Please.
Yeah, I'm not serious. 100%. If I'm wrong, then I owe you 100, 250 euros.
No, that's okay. Yeah, you're right.
Yes.
Yeah, you're right.
Only 9 people. He's right. See, I put the project on the line.
Pedro, do you have a list? The list of 10 people who won?
These are 9. There's one more.
There's one more. We'll cross-check this quickly. Let's have the photo first. Yeah, actually, let's have the photo first, and then we'll announce it. Yeah. Can all of you come inside over there? Can you all sit inside? Just for a quick minute, we'll click a photo and then you're ready to go.
Yes, you worked hard. You worked hard and you deserve that. So what you
Wow.
Joyce, Catherine, come. Yeah, come. Quickly. All the photos that people get will be from them, so you should be there. Yeah.
Yes.
Just from front.
Yeah.
You're gonna be in the photo. It's just yeah. Ready? Yes.
Just keep smiling. Alright, let me check. Okay, no. Okay.
I think we have multiple.
Thank you.
Claro. Who is the 10th? Who is? You know.
Okay, so the 10th person was JJ Olajatan. JJ. He's gone? No problem, we'll contact him. And thank you so much everyone for waiting around.
Also, before you leave, guys, please a special thanks to our lead organizer, Sair, and our co-lead organizer, Nish, for the whole effort they put here, and for sorting this event out for you.